Hi and welcome to this course. I'm really excited to see every one of you here, and I can't wait to show you what TypeScript does. TypeScript is a programming language that has been built on top of JavaScript. It is actually a superset of JavaScript, which basically means that it can do what JavaScript does, and it can do so much more. TypeScript has risen tremendously in popularity during the recent years, so much so that it has become an integral part of getting a web development job. So if you want to get a web development job, you need to really learn, understand, and master TypeScript. And that is why I've created this course. This course is perfect for you because this is not your typical TypeScript course. We're going to start with the absolute basics of TypeScript. And we're going to work our way up by talking about a lot of major TypeScript concepts, relevant TypeScript concepts, modern TypeScript concepts, through a lot of examples as well as challenges. So every concept that you're going to study in this course, it is going to be accompanied by one or more challenges just to make sure everything sinks right in. I've had a lot of fun creating this course, and I've made sure that it upholds the highest standards of the TypeScript programming language. And I promise you that I'm going to make sure that I have made sure during this course that your transition from JavaScript to TypeScript is going to be as smooth and as comfortable as possible. So without further ado, let's get started, enroll in this course, and let's get started with this journey. See you in the course. Hi and welcome to this video. In this video, I would like to give you a brief overview of what we're going to study in this course. So let's go ahead and let's get started without further ado. The first thing that we're going to discuss is going to be how to set up TypeScript, where we're going to talk about the code editor, creating TypeScript environment, and just having like very basic, working with very basic TypeScript examples. From that point onwards, we're going to talk about some very rudimentary and primitive types in TypeScript, which include primitives, any array tuple, and the enum type. From there, we're going to talk about conditionals and loops in TypeScript. Since TypeScript is a superset of JavaScript, these are going to be very easy. The aim of this course is to make sure this transition is easy for you from JavaScript to TypeScript. That is why the first few sections, they're going to be extremely easy. And after that, we're going to have the first part of Let's Get You Coding Challenges. These coding challenges are designed to make sure you put into practice all the concepts you study from previous section. And there are going to be a lot more of these challenges after once we study one section. So this is part one, and then after that is completed, we are going to jump into talking about TypeScript functions. We're going to see how we can create function declarations, function expressions, and arrow functions. And then you're going to have your second part of coding challenges. These coding challenges, the solution and the challenges are included within the resource files. You can take a look at the challenge, then solve it, and then just cross-reference it with the solution. And if you're still not sure, there is going to be a video accompanying every single challenge's solution. And that is going to be on whiteboard, which is really exciting. From that point, we're going to talk about some TypeScript basic types. As you can see, we have a lot to talk about, like the void, never, and then we're going to talk about some very important concepts such as recursive, type aliases, typecasting, union types, literal types, intersection types, and so much more. So the idea behind all these basic types is to give you a very solid foundation for your TypeScript knowledge. And then using and leveraging this foundation, you'll be able to understand all of our upcoming sections. After that section, you're going to have your third part of coding challenges. And from that point onwards, we're going to talk about some basic built-in types in TypeScript, like the array type, the object types, the function types, and the function inferences, sets. And then you're going to have your fourth part of coding challenges. And then we are going to talk about an idea in TypeScript that is called type narrowing and type widening. What are their advantages? What are their disadvantages? Where we can use them? And what problems they aim to solve for us. Right after that, you're going to have your fifth part of coding challenges. And this is what I meant by telling you in our first video course introduction that this is not your typical TypeScript course. There is a lot of challenges just to make sure you really understand everything and you put into practice. A major difference point between TypeScript and JavaScript is that TypeScript has interfaces. We're going to talk about what an interface is, interface methods, how we can extend interfaces, we can augment them, and what are generic interfaces. Then you're going to have challenges for interfaces. Then we're going to talk about another section that is going to be dedicated to a lot of advanced concepts in intermediate to advanced concepts in TypeScript. These concepts that we're going to study in this section, they're going to play a major role when we want to understand TypeScript documentation and TypeScript source code. And these are also included within that section as well. Partial types, read-only types, the read-only array. And what I wanted to do was end this Beyond Basic Types section by talking about some newer JavaScript and how they incorporate into TypeScript, such as optional chaining and knowledge coalescing. Then you're going to have your seventh part of coding challenges. And right after that, we're going to talk about enums, which is another very cool part of TypeScript. And we're going to talk about the basics. I'm going to give you examples, and we're going to talk about constant and computed enums, string enums, and finally, we're going to finish this section by talking about exhaustiveness checking. Then you're going to have challenges for enums. Right after that, we're going to talk about the most important concept in our course, that is object-oriented programming. And there is going to be a complete section, a lot of lectures, and we're going to dig very deep into this topic. And we are going to talk about these ideas as well. So you saw some of them in the previous slide. In this one, I'm just showing you what other concepts we are going to talk about in our object-oriented section. And then we're going to have our ninth part of the coding challenge. And this is where actually, that was where actually beginner to intermediate TypeScript ended. And this is where the advanced TypeScript starts. We're going to start talking about type queries, which are type of and key of. Then I'm going to talk about conditional types, which are, and I'm going to give you examples as well. And then we're going to talk about utility types, which are extract and include. All of these are prerequisites to understanding how map types work. I'm going to show you TypeScript source code, how the source code works, how you can incorporate source code into your own projects to build better projects, more professional projects, and projects that other people can really understand. From that point onward, we're going to jump into the world of developer tools. I'm going to show you how you can come up with creating TypeScript modules. I'm going to show you can create a TypeScript project, import code, re-exporting, exporting and importing, default exporting, and also we're going to talk about export assignment, conditional loading, and a lot more skills that you need to master if you want to become the next level TypeScript developer. Right after that, we are going to talk about TypeScript and Webpack, where we're going to talk about how we can watch for file changes, how we can extend recommended configurations, and how we can use single file compilations to compile our projects into a single file. And that is it for this video. See you in the next one. Since TypeScript is a superset of JavaScript, there is actually one prerequisite to this course, and that is beginner level knowledge of JavaScript. If you're not an expert of JavaScript, that is cool. If you're not an intermediate JavaScript developer, that is also cool. What I require from you is a little bit knowledge of JavaScript so you know how variables are declared, how functions are created, how loops work, how conditionals work, how you can create a conditional, and these very, very minimal and basic stuff. And from that point onward, I'm going to take your hand and I'm going to guide you through the road that is TypeScript. What is TypeScript? TypeScript is a statically typed, object-oriented programming language that was created by Microsoft in the year 2012. TypeScript is a superset of JavaScript, which means TypeScript extends the capabilities of JavaScript by adding type safety and type checking to JavaScript data types, classes, and other object-oriented features. The idea behind TypeScript is that TypeScript is created to be used for medium to large scale applications. And if you have smaller applications in scope, it would be recommended to use JavaScript, since TypeScript is mainly created to be leveraged when it comes to production grade applications. Since TypeScript has become so popular in the world of web development, we can use TypeScript to write client-side code with React and Angular. We can also use TypeScript to write server-side code with Node.js. So TypeScript is an extremely powerful and popular programming language, and this is the best time to learn, understand, and master TypeScript and leverage TypeScript to create better, more advanced, and more performant web applications that would make it easy for other developers to collaborate on as well. Hi everyone. In this video, I would like to talk about the differences between TypeScript and JavaScript. TypeScript is a statically typed programming language, which means we need to type annotate our variables at the time of declaring them. There is also a compile stage required, since TypeScript cannot be loaded directly into the browser. This compilation stage is really important for TypeScript, since this is what is the most important feature of TypeScript, and this helps us to catch errors during compilation before compiling or transpiling our TypeScript code into JavaScript so it can be served to the browser. JavaScript, on the other hand, is a dynamic programming language where the type of variables are determined at runtime. It is an interpreted programming language, which means there is no compilation stage, and we directly serve our code to the browser, and the browser can read and understand JavaScript. While this is an advantage, there is also a downside to being an interpreted programming language, where we cannot find our bugs and errors until we have served our application. Whereas with TypeScript, before transpiling the code into JavaScript, we are going to find out what the errors are during the compilation stage, and we are going to remove those bugs, and then we're going to compile our TypeScript to JavaScript. Therefore, our TypeScript projects are less bug prone than typical JavaScript projects. On the screen, I have two code snippets. On the left, we have TypeScript, and on the right, we have JavaScript. On the left, we can see we have a variable called score, and there seems to be something extra there, :number. That :number basically means that we have type annotated our variable with the type of number. The reason that we do this is because TypeScript is a statically typed language. Now, as soon as we do type annotate our variable to number, we cannot store any other data type there. But JavaScript, on the other hand, is a dynamic programming language. And what that means is when I say score is 95, later on, I can go ahead and I can change that score to a string or whatever I want. But TypeScript is not going to allow me to do that. This is one of the very basic yet extremely important differences between TypeScript and JavaScript. That is it for this video. See you in the next one. Hi everyone, in this video I would like to introduce you to TypeScript Playground. TypeScript Playground is an online code editor for TypeScript that has been provided by the TypeScript official webpage. So what you're going to do is you're going to go to typescriptlang.org, and in here this is the official documentation page, the official page of TypeScript, where we can see what actually TypeScript is. TypeScript is JavaScript but with syntax for types. We're going to explore what syntax for types mean, what it means, and it also says here TypeScript is JavaScript and more. It produces a result that you can trust, and when you scale your application, basically in production, it is really, really safe. So you can go over this website. I do recommend you go over them. Go over this website. There is also there is an handbook that you can use. There is the documentation for TypeScript. Here is the documentation. If you have any issue with any part of the code, you could ask me, or you could just jump into this documentation where they have a PDF version or an EPUB version as well. Here is the handbook that has been provided by the official TypeScript team. So what I'm going to do is from here, I'm just going to click on Playground, and you can see that this is a playground for TypeScript. We don't have any kind of VS Code. We don't have anything. We don't need to install anything, and it is ready. And I do suggest you start working with this and try to write plain JavaScript code and see how it actually works. So I'm going to go over everything that you can see on the screen. First, I need to zoom a little in. Just zoom in a little bit more, maybe a little bit more. There we go. So on the left here, we have TypeScript code. Don't worry if this is not familiar for you, because we are going to go over this a lot. Don't worry about this. Here is a function that adds two numbers together, that is A and B. In the function signature, we have provided two parameters, parameter A and parameter B. The type of parameter A is number, type of parameter B is also a number. This is how we type annotate variables or identifiers in TypeScript. We provide a colon and then we specify what type it should be. And as soon as I specify what type it should be, we can't pass in any other type, like in this case. So I've said here it has specified that the type of the parameter B, it has to be number. And when we pass in a string, there is an error there. And the error says argument of type string is not assignable to parameter of type number. Again, don't worry about this. I'm going to explore all of this several times throughout this course. Now, let's head over to the right side of the window. Here we can see here is our JavaScript. And the first thing that you can see is an extremely recommended way of writing JavaScript, that is writing JavaScript in the strict mode. And the idea behind TypeScript is that when you take away all the type annotations, what you are ending up with, it has to be JavaScript. Otherwise, you're doing something wrong. So if I take out this number, just remove that, remove this one as well, perhaps remove this one. And now you can see this is exactly like that what we have on the right side. So when we take away the type annotations, all of them have to match. The first panel is .js, which means this is what the JS code is going to look like. Then we have our declaration files. We're going to talk about these. In fact, I've dedicated a couple of lectures for this one. These are extremely advanced stuff, so don't worry about it here. This is our errors log, where it is specifically saying what the error is, and we have nothing in the log itself. On the top, in here down below the playground, we can see the version of TypeScript. You can select it from here. You can click on this run where it's going to run it. You can also export TypeScript. You can share it as well. On the top, a little bit above, we can see here we have our TypeScript config, where it basically shows you what the configuration for the current project is. Don't worry about it. We're going to talk about that. Here we have examples. For example, you want to work with primitives. These are the examples. Type primitive. We're going to explore these meta types, language, language extensions. So don't worry, we're going to explore about 95% of everything you can see right here. All right. So I do suggest going to typescriptlang.org, going to this playground, clicking on the playground, coming here and basically trying to write something in TypeScript, trying to type annotate them, because this playground doesn't really require you to provide any kind, to have VS Code, to install TypeScript, to do any kind of configuration. You can just plug your code in. It is also a very good idea for testing. If you want to just test your code extremely quickly, you can just put it right here and take a look at the errors, take a look at the declaration file for them. So make sure to check this one out as well. That is it for this video. See you in the next one.
Hi and welcome to this section. In this section, we're going to get started with the TypeScript setup. But we are going to need some sort of code editor to get started writing TypeScript. And I'm going to use VS Code, which I'm sure you're familiar with, and I do recommend it. However, you can use whichever one you like. We're going to talk about how we can install TypeScript, and from that point onwards, we're going to see how we can write plain old JavaScript in our TypeScript, and we're going to take a look at an example of TypeScript as well. Since TypeScript cannot run in the browser, we're going to need some sort of compilation stage or transpilation stage. And for that matter, we're going to talk about some configurations for the TypeScript projects.
Hi everyone. In this video, we are going to get started with the environment setup for TypeScript. The setup is going to be very simple. The first thing that we are going to need is Node.js, which is a JavaScript runtime. You can get this by going to nodejs.org. And when you come here, you're going to see two different versions. Since I am on a Windows machine, I'm seeing Windows x64, and you're going to see, depending on what kind of operating system you're on, you're going to see your OS-specific version to install. You can grab this LTS, which is long time support, or you can grab the current version. For most cases, this is recommended, this LTS version, but you can grab the current version as well. Click on it. It is going to download the installer, install it. It's got a very simple, like click, next, and finish setup. It's very simple. After that, what we are going to do is we are going to open VS Code. For this course, I will be using VS Code, and I recommend that you use VS Code as well. And if I take a look at my desktop right here, you can see there is a TypeScript -setup folder that I've opened up in VS Code. It is visible right here in here, TypeScript setup. It also says on the top of the file that says, top of this software that says TypeScript -setup. Now within here, in this video, we're not going to write any kind of code. We need to install TypeScript first. Now, the way that we're going to install it is we're going to go to terminal and we're going to click on new terminal. You can open this new terminal like that, or you can just do control and backtick, and it's going to open up this terminal for you. And in here, you're going to say npm install, and we're going to add a flag that is going to be -g, which means it's going to install it globally. And then what is the package that we want to install? It is TypeScript. It's not going to take long. For me, usually it takes like around 40 to 50 seconds. And now it was even faster. It took around like 2 seconds. And now that TypeScript has been installed, we can take a look at the TypeScript version. So for that, you're going to do, I'm going to zoom in so you can really see what is happening here. We did npm install -g TypeScript. This installed TypeScript on this machine. And to be able to know for sure that TypeScript has been installed, we are going to write tsc space -v, which means like -v, which is going to give us the current version. And the current version of TypeScript at the time of recording this video is 4.8.4. We have already talked about how TypeScript is a superset of JavaScript. And any valid JavaScript code can also run in TypeScript. Now, in this video, what I would like to do is I would like to actually give you a live example of how you can run any JavaScript code within TypeScript as well. There are going to be some limitations when it comes to the actual TypeScript realm of type safety and type guarding, which we are going to talk about throughout this bootcamp, don't worry. But as for the general notion, is that every JavaScript line is actually could run within TypeScript as well, as long as it doesn't violate any of TypeScript's rules. I'm not going to get into any more technicality. We are just going to talk about a very simple code, and that's basically the code that we do in every program that we start teaching. And what I'm going to do is first, let's create a TypeScript file. Since this is the third video in this section, I'm going to name this 3-JS. This is JavaScript in TypeScript. So I'm going to say JS in hyphen and then TypeScript. The extension for a TypeScript file is .ts. And as soon as I save it, you can see this is a TypeScript logo. This is a TypeScript file. Let's go ahead and let's say console.log hello world. And as soon as I save it, nothing really happens here because we didn't actually do anything with this program. We could print it to the terminal, and for that we're going to do node and then the name of this file, which is 3-js-in and then TypeScript. Do not forget the extension .ts, and as soon as I do that, you can see it says hello world. So this is a valid TypeScript program. But how would I compile this into JavaScript? Since TypeScript, we have already talked about this, cannot be read directly by the browser. We need to grab our code, translate it into pure or vanilla JS or JavaScript, and then the browser can understand JavaScript. But the browser does not understand TypeScript. And this is not how we create projects. So we compile it or transpile our TypeScript code to JavaScript code so the browser can understand it. How would we do that? We are going to create a JavaScript file, and in our upcoming sections, I'm going to show you how we can create that automatically. You're going to run a command in the terminal, and it's going to watch for all the changes, and it's going to create that file automatically for you, so you don't have to run this command over and over again. The command is tsc, and then the name of the file, the TypeScript file that you want to compile into vanilla JavaScript. And as soon as I do up arrow, it's going to copy for me node. I'm going to get rid of the node, and I'm going to do tsc. So instead of typing all of this, I just did the up arrow. And then, you know what, I could remove it so you can really see what is happening. So there is nothing here. I'm going to do the up arrow. It's going to copy the above line below. And I'm going to change node with tsc. And as soon as I hit enter, might take like a couple of seconds, it has created for us a JavaScript file. And as I click in it, you can see that it has the same code. I'm going to open it here. So we have console log hello world here, and we have console log hello world here. And if we had an index.html file, we would see this in the browser as well. So I'm going to do an index.html file here, and let's generate a simple boilerplate for HTML. I'm going to put this on the left since I'm used to it here. Let's grab our JavaScript file. This is 3.js. There we go. Now our JavaScript file is linked to the HTML, and then our TypeScript file is linked to JavaScript. So anything I do from within this TypeScript file, it's going to change the JavaScript for me, and JavaScript is going to show within the browser. So I'm going to change this to hello TypeScript. And as soon as I save it, it doesn't do anything because we need to run this command. tsc that file, and now it is going to change it for us. There we go. So it says hello TypeScript, and I'm going to open this up with live server, and there we go. Very cool. And if I jump into the inspect from here, let's reload this page one more time. There we go. Hello TypeScript. So far everything is making sense. There is a couple of things that I would like to show you, and then I'm gonna wrap this video up. The first thing is this prettier code formatter that I've installed, and I'm pretty sure you have this installed as well. This is going to format our code. For TypeScript code, it's going to allow us to write more professional code. And you can see all these supported languages and technologies right here. Now, to be able to enable this for TypeScript, what you're going to do is you're going to do Control Shift P or Command Shift P on Mac. I hope it's Command Shift P. And you're going to go to Open User Settings, JSON User Settings. And the shortcut is Control plus Shift plus the P button. And when you click on it, it's going to open up this JSON file. And within this JSON file, you can see I've added this TypeScript. So the TypeScript editor.default formatter is this prettier VS Code. The easiest way would be to just copy this down below and change JavaScript to TypeScript. Make sure all of the name of TypeScript is in lowercase. So that's one thing that you need to do. And the second thing, I'm pretty sure you already know that since you are coming from JavaScript, and that is format on save. And it has to be ticked marked. Otherwise, if you save this, you need to run Control Shift P format document every time, which is like a lot of wasted time. So you're going to say, okay, as soon as I save the file, format the file as well. And it's going to format it for you. Cool. Everything is okay so far. And that's it for this video. See you in the next one. The first thing that I would like to do here is let's go ahead and create a TypeScript file, not JavaScript, of course. And it's going to be for-TypeScript-exemplified.ts. I'm going to give you an example of creating a variable. Since you're coming from JavaScript, you already know what a variable is. You should already know what a variable is and why do we need to create variables. And the way that we create variables in JavaScript would be using either the let keyword or the const keyword. And then we would specify the variable name. In this case, the variable name is grade. And then we would provide a value for this grade. And the value is going to be 95. So this grade variable is a kind of container that holds this value, which is 95. Now, this is valid TypeScript code, and there is something happening behind the scenes. TypeScript is doing something that is called type inference. We're going to talk about that in our upcoming sections, but what it basically means is that since we have not specified explicitly what the type of grade is, TypeScript is inferring that for us. And as soon as I hover on this grade, you can see it says let grade : number. So what is the type of grade? The type of grade depends on what it holds, what it is storing. So if a variable is storing a string, the type of that variable is string. If a variable is storing a number, then the type of that variable is number. If it is storing true or false, then the type of that variable is Boolean. So depending on what the variable is actually been assigned to, the type of variable is going to be different. In this case, taking a look at the value for this variable, TypeScript knows that 95 is a number, so it assumes or it infers the type of grade as number. But this is not actually good practice TypeScript code. We need to annotate our variables. Annotating means when you provide a specific type to a variable. And we do colon and then the type of that variable. What kind of data type is this? It is a number. And now it is a valid and best practice TypeScript code. And the good thing about TypeScript is that once you define this number, this grade, which when you set it to a number, you can't change it because TypeScript is a statically typed language. Types are static. You cannot change them. That is the good thing about TypeScript. That is why you want to learn it, because it's a good thing. It's a good programming language. Now, we can take a look at that. So if I were to say grade, since I know grade is a number, but let's say down the line, in our application, like many tens of lines later, I forget that it is a number. It is a number, and I forget the value, and I change its type from 95 to a string of 90 and 5. And as soon as I do that, it doesn't matter whether I save it or whether I don't save it. We are going to see that underline, which is an error. It's not a warning, it's an error in TypeScript. And let's hover on the error and let's understand what that error is actually telling us. By hovering, we can see first it gives us a quick preview of what this grade actually is, what kind of data type it is. It is of type number, so we have annotated it with type number. And here is the actual error. It says type string is not assignable to type number. What does that mean? So I'm going to copy this so I can dissect it line by line for you. It says this is actually a type error in TypeScript. This is called a type error, and it says type string is not assignable to type number. Now we know that this equality sign is the assignment operator. I'm going to zoom in for this so you can really understand it, because in my opinion, this error lies at the heart of TypeScript. This is what makes TypeScript TypeScript. So it's very important that you actually understand what this error is and what it is actually saying. It is a type error. So type string is not assignable. Assignable means this equality sign. Type string means this part of the equality sign. So the right part of the equality sign, which is of type string, is not assignable, which means it is not equal to type number, which is on the right side. Even though the variable name says grade, but what type is grade? It is a number. That's why 95, which basically is a string, cannot be assigned to something that has a type of number. And you can see that it clearly says type string is not assignable to type number. It's not saying that the string of 95 is not assignable to the variable of grade or to this identifier of grade. It is clearly telling us that there is a type error, that we have made a mistake in typing our variables, which means once you specify a variable, any type, you cannot change its type in TypeScript. Cool? Hi everyone, in this video we are going to take a look at the TypeScript compiler. The TypeScript compiler is the set of settings or the compilation of settings that are actually responsible for converting or transpiling or compiling our TypeScript code to JavaScript. How all of our TypeScript code is compiled into JavaScript is the job of TypeScript compiler. That's why it's called compiler. That compiler decides what to do, what not to do, what errors to pass, what errors to hold, and everything you can think of when it comes to TypeScript. Now, within this directory, we can see we don't have any kind of setting or file that denotes that it is a TypeScript compiler. That is because we need to generate the TypeScript compiler. And before generating, I need to tell you that there are some settings that are there by default. We got those when we installed the actual TypeScript. So the way that we can access the TypeScript compiler for this specific project or directory is we need to go to terminal. And I'm going to bring this up and let's clear everything out. And in here, you're only going to have to type a very simple thing. You're going to say TSC, short for TypeScript, and then you're going to do hyphen hyphen init hyphen hyphen init. And let's hit enter. There we go. It just created for us the TS config file, a TypeScript configuration file. And we can see that in here. There we go. And I'm going to click on it. And I need to tell you that there is going to be a ton of, I'm going to zoom out so you can really see how massive this JSON file actually is. But don't worry, we are going to talk about some of these, but there is actually a description for each of them right in front of them, like a very short description. You can refer to it, but you're never going to need to understand all of them. But they are there for reference purposes if you would like to reference them. Now, let's first talk about this one. This says language and environment. The target for our language and environment is ES 2016. It says this basically means that when we compile our TypeScript code, it's not going to be compiled to JavaScript versions pre-ES 2016. It's going to be compiled to JavaScript version of starting from ES 2016 and upwards, like modern JavaScript. Cool. So this is the first setting. And the next setting that I would like to talk about, which is very, very important. This is not that important setting, but we are going to get to it. This basically says the module that is going to be created when we are running the code. Now, within this module, we have this root directory. The root directory specifies the root of our TypeScript files. So when I am transpiling or compiling my TypeScript to JavaScript, where is that folder that holds all the TypeScript? Where is it? We need to specify it right here. So I'm going to get rid of these two forward slashes. I'm going to comment that in, and I'm going to pass in here a folder called src. And we need to create this folder as well. I'm going to create this folder. You can see we got 2 errors. This error basically says that you don't have that folder yet. So I'm going to create a folder that is src. There we go. We have created that folder, and it is within this same directory. And within this directory, we're going to have all of our TypeScript files. So I'm going to grab this file, and I'm going to grab this file, and I'm going to move both of them within the source. There we go. So now both of them are actually within the source file. And now you can see the error is actually gone because we actually did what we specified right here. Now, this is the source of our TypeScript files. And I don't want my JavaScript to be like casually thrown around within the Explorer. I want this JavaScript to be actually within a different folder. So I'm going to get rid of this. I'm going to delete it immediately. There we go. And I want it to be within a dist folder or a distributable folder or up folder, because that folder is going to be the folder that we are going to be uploading to the internet for our website. And that is going to be decided by the out dir. Where is it? This was the root dir. We have root dirs. Where is the out dir? It has to be right around here. There we go. So this decides this setting. You can see I'm commenting it in. This decides where the output of our JavaScript files will be. So I'm saying that it has to be within a folder called dist. And as soon as I save this, well, of course, nothing happens because we need to run our TypeScript. Cool. We're going to get to that. Don't worry about it. And there is another setting that I would like to comment in as well, and that is remove comments. If we have any kind of comment in here, TS is a superset of JS. So this is a comment. By preference, I don't want the comments that I have within my TypeScript file to also be transpiled to JavaScript. I don't want the comments to go to JavaScript. I just want the actual code to go to JavaScript. I don't want the comments to go. So there is actually this setting that says remove comments, and it is set to true, and I'm going to comment that one in. And there is one more setting that I would like to comment in, and that is easy. That is very simple as well, and that is when we have any kind of error in our TypeScript file, I don't want to create a JavaScript file because I have a bug in my TS file. Why would I want that bug to be transferred or transpiled into a JS file? I wouldn't want that. So if I have an error, it means that I don't want that code to be transpiled to JS until I fix that error. As long as it is not fixed, do not send it to JavaScript. And it is within this category. It is no emit on error. Where can I find it? This is strict typing. Where is, I could say no emit on error. There we go. It's right here. And I'm going to get rid of that. There we go. And I'm going to comment this one in, and I'm going to save that. And as soon as we save it, we are not No longer when we have any kind of errors, it's going to actually go to our it's going to go to the JavaScript. As long as there are errors in our TypeScript files, it's not going to go to our JavaScript files. And I think that is a good thing, right? And there are like a ton of other settings, but I'm not going to go over them. And what I would like to do is I would like to remove all of the other ones. And there are going to be a few other settings that I'm going to be adding in our upcoming sections. And that's going to be it for it. And I don't want to like have you overwhelmed with all of the setting right here. So I'm going to get rid of all of this. There we go. And from what I'm going to do is from this video onwards, for every folder or section, I'm going to generate this tsconfig file. And then I'm going to copy all the configuration from this file into that file. And that's going to make the process a lot smoother and simpler, right? Let me get rid of them all the way to here. And you can see it is a lot more manageable right now. Cool. And I'm going to get rid of these as well. We don't really need them. We know what they are. And you can always just create a tsconfig file or compiler options to actually tell you what they are. Very simple stuff so far. This is basically setup. It's going to take like a couple of minutes and then we are done. There we go, right up until here. I'm going to get rid of that and I'm going to get rid of, okay, make sure not to delete anything else. And there we go. I think this is way more manageable than what we had previously. And you know exactly what these are doing. So there is actually this one as well that is strict. This is gonna, whenever we compile our TypeScript to JavaScript, it is going to ensure that our JavaScript is actually in strict mode. It's going to allow us to write better code. Now, how are we going to be able to transpile all of our TypeScript files? Not manually, but automatically, all of the TypeScript files from the source folder into the dist folder transpiled into JS. That is something that we're going to discuss in our next section. See you then.
Hi and welcome to this section. In this section, we're going to get started with types in TypeScript. Since the most important feature of TypeScript is type safety, it is of utmost importance for you to understand how type annotations work. And that's why we are going to start at the very basics. We are going to talk about numbers, booleans, and strings. And from that point onwards, we are going to talk about more built-in types in TypeScript, such as the any type, the array type, and so on.
Hi everyone, in this video we're going to talk about number, string, and boolean types. Before jumping into all of that, first things first, we need to create a source folder, remember? And then within the source folder, we need to put all of our TypeScript files. So what I would like to do is I would like to right click on it and say new file, and I'm going to put that name there, and it's going to be number, string, boolean types, which we are going to cover in this video. We need to generate that tsconfig file as well, and we know how we can generate that. That is tsc ---- init. It has generated for us that tsconfig file. I'm going to select everything, delete everything, and I'm going to come back to this folder. This is something that I'm not going to do anymore. This is the first time that I'm doing it in front of you, just to show you how it is done. After that file is opened, it is going to open. If you just double click on it, it's going to open VS Code. Since I have VS Code in the other screen that you're not seeing, I just copied it from there. And this is everything we have been talking about in our previous section. Everything looks awesome so far. Now, what I would like to do is I would like to show you how you can create all these files, all of this automatically. All the changes, as soon as you do Control S, all the changes will be automatically reflected into JavaScript files. You're going to do tsc-w. This is going to watch for all the changes. And there we go. It is basically watching. And as soon as you do that, it has created a dist folder for us. And what do we have within the dist folder? We're going to have a number string boolean hyphen types .js file, which is going to be empty. So I'm just going to double click on it. Now within this dist folder, what I would like to do is I would like to add an index.html file as well, index.html, because I would like to show you the result in the console for the browser as well. I'm going to close this. Everything looks okay. I'm going to bring the index.js file all the way to the right. Make sure not to close this terminal. I'm just going to bring it down just to have less focus on it. Within here, we're going to do this is going to be the name of this section, getting started with types and TypeScript. And the S is not actually capital according to documentation, but anyway. Getting started with types in TypeScript. And in here, I'm going to add that JS file. Source is going to be 2.js. There we go. And in every other lesson, I will do all of this. For every other section, I'll do all of this. But for every other lesson, I'm going to insert the script actually before hitting record. Because when I hit record, I don't want to waste your time on all of this. This is very simple. This is actually our development environment, workflow, or you can call it workflow. And I'm gonna, you know what? I'm gonna get rid of that index.js file, and you can see we have that use strict right here. Now, what I would like to do is I would like to open this index.html file with live server, which is an extension you can grab from the marketplace. If you don't have it, you just have to type live server and install it, and that's it. That's going to give you a live server, and you don't have to refresh the browser. So here is the browser. I'm going to put browser and editor side by side. Here is our editor. There we go. And I'm going to make this window this small. Let's jump into the inspect, zoom out a little bit, go to the console. There we go. I think this is cool. Now it's not going to be that readable for me to switch between these two windows. So what I would like to do is there are two things that I could do. I could open this in another view like this. So these two could be side by side, but I think this is not enough real estate since I'm a lot zoomed in so you can really see the code. I don't think this is going to solve the issue. So what I would like to do is, and I'm going to do all of this before hitting record for our upcoming videos. Keep that in mind. I'm going to come here and you can see this split window, and I'm going to hold Alt and it immediately changes to a window top and bottom. And as soon as I click on it, I'm going to get rid of this. So on the top, what do we have? We have the 2.ts file. You can see this is TypeScript. The logo is blue. And on the bottom, we are going to have the compiled JavaScript file. Cool. Now that our environment has been set up, we are going to jump into TypeScript. And we are going to see our result live in the JavaScript. And then that result through live server is going to jump into the console, and we're going to see it in the console as well. So the first thing that I would like to talk about are the number, string, and Boolean types in TypeScript. Now, there are several data types in JavaScript, such as number, string, Boolean, undefined, null, object. TypeScript uses all of the JavaScript data types, plus adds more of its own, such as any, unknown, never, enum, tuple, or tuple, which we're going to cover for the most part. Now, first, we're going to explore some of the primitive data types of JavaScript, but in the context of TypeScript. The first primitive type that we're going to explore in TypeScript is the number type. So first, let's go ahead and let's take a look at that. So I'm going to say let course price. Now, this is the variable. I'm intending to assign it a number. Therefore, I'm going to annotate it with a type number. Whenever you provide a type to a variable, Technically, it's called type annotation, or you're annotating this course price variable with the type number. These are very simple stuff. And I'm saying, okay, the price of this course is like, let's say, $19.99. And as soon as I save it, you're going to see that immediately that code being transpiled or converted into JavaScript or compiled to JavaScript. And it grabs all the changes right here. There we go. This is how we work with numbers in TypeScript, creating numbers. Very straightforward. There's nothing more to it. And as I hover on it, you can see the number type has been shown here as well. We cannot change a type. Once we have set that to a number, we can change it to, I don't know, like 10. Since this is a string, it's not going to work. And we have talked about this a lot. That's why I'm just going to comment this one out. And let's go ahead and let's create another type. So the reason that I'm just moving past this number is because we talked a lot about the number, right? And I don't want to talk about it anymore, and I want to talk about strings. But there is something that I would like to point your attention to, and that is this course price. This course price is now a comment, and it doesn't matter how many times I save it, it's not going to be compiled into JavaScript because of that because of this that we have said remove comments. If I set it to false and if I save it, and now if I come into JavaScript, you can see we see that comment. Keep that in mind. These settings are here for a reason, and now we don't see it anymore. And all the changes are being compiled live. You don't have to do anything. So this improves your developer experience a lot. Now, creating a string is very simple. I'm going to say let course name. Now, I want to provide within to this variable a string, whatever that string is. So I need to annotate it with the type string. Cool stuff, right? I'm going to say TS bootcamp. I'm going to keep it short. And as soon as I save it, you can see the changes within the JavaScript file as well. So far, everything is making sense, right? And finally, what I would like to do is I would like to talk about the Boolean type. Within the Boolean type, we just have two values. So numbers could be anything, any number, 0, like negative infinity, positive infinity, and strings could be, again, like infinite number. But Booleans, they can have only two values. They could either be true or they could be false. Cool. So if I say let past, and I want this say to either true or false, so a proper type annotation would be like Boolean. So it's either true or it's either false. And as soon as we see save it, we can see the changes right here. You don't have to do anything else. Now, there was another setting that I actually turned on, that was no emit on error. And what I would like to do is I would like to turn that off. Let's come here. It's no emit on error, and I'm going to set it to false. Cool. And I'm going to actually do something that is going to arise an error. I'm going to grab this past because it has a type of Boolean, and I'm going to set it to a number of 1. Cool. And as soon as I hover on this, it is going to say type number is not assignable to type Boolean. Keep in mind, these type errors, they start from the right side of the assignment. So type number is not assignable to type Boolean. So it starts from right and it goes towards the left. But when I save it, we can see that even though there is an error, the code has been compiled into JavaScript. That is not, this completely beats the point of TypeScript. This is not something that I want. And that's why we're going to come back to here and we're going to say no emit on error, and we are going to set it to true. And as soon as it has been compiled, it can't do anything else. The code doesn't run. But if I comment this one out, save it, and if I comment this one back in and I save it again, we don't see that code anymore. And until you don't get rid of this error, no code is going to run. Keep that in mind. That is one thing that I wanted to show you, and I'm going to show you how this JavaScript is going to be shown in the browser as well. And then we are done. So we have a course name, Then we have a course price, and let's save that. There we go. So we know that the course name is TS Bootcamp and the course price is 19.99. Hi everyone, in this video I'm going to talk about the any type. The any type is a built-in TypeScript type. The any type is used to represent any type of value, literally any type of value. It is used in two cases. It is used when we don't know what type of the variable is, what the type of the variable is going to be, because we don't know what the variable is going to hold. And the second condition would be when, or the second situation would be when we don't want the type of the variable to be anything else. We want it to be specifically and explicitly the any type. It's literally any. So when we say any in TypeScript, it could be any type. It could be type number, type string, type boolean. And in fact, this is a bad practice. We should avoid using any. And I'm gonna tell you why towards the end of this lecture. So let's create a variable called password, and I'm gonna declare this variable, and I'm not gonna define it a value, or this is an uninitialized variable. It doesn't have a value. And as soon as I save it, we can see it has been compiled to JavaScript. I'm not gonna talk about that, but let's hover on this variable. And as I hover on it, you can see it says let password, and we know after the colon we have the type. So what is the type? The type says any. The TypeScript compiler does not know how to handle this type. That's why it annotates it as type any. Now the issue with this is this password variable, it could be a number. And there are no errors. You can see that. There are no errors. You can see there is no error in the TypeScript. There is no squiggly red line, or the second way that you know there are no errors is if there were, then the code would not have been compiled to JavaScript. So now the type of this any variable is password, but it could very well be a string. And still there are no errors. Now, the issue with this code is that by declaring the type of any variable any, we lose the core functionality of TypeScript, and that is type checking. Since TypeScript cannot fully understand the type of this password, the type of this password variable, it is toggling between number and string, and this is a highly bad practice in the world of TypeScript. Because when we do this, this is no different than writing code within a plain vanilla JS file. And it's like we're not using TypeScript at all. And that beats the whole idea of TypeScript. We are losing the core functionality upon which TypeScript was created, for which TypeScript was created. So the key point to take away from this lesson is never define the type any for any of your variables. If you don't know what it is, probably you don't need it. And if you don't know what kind of variable it holds, then do not specify it, do not declare it. Cool. See you in the next video. The array type in TypeScript is used to create arrays, similar to the array type that we have in JavaScript. However, unlike vanilla JavaScript, in TypeScript we can have arrays with only one data type, unless otherwise specified. So what I'm going to do is, let's create our very first array. I'm going to say I want to create an array of numbers. And I'm going to pass in 1, 2, 3, 4, and 5. And I'm going to save this. It has been transpiled to JavaScript. Let's hover on this and let's see what it shows us. So as soon as I hover on it, we can see that after the colon, the type annotation says it is a number, and then we have this array syntax. So it is an array of type number. What does that mean? It means within this array, we can only have numbers. Watch what happens if I say hi. As soon as I say hi, it is going to change the type of this numbers array. Now, this might look a little bit confusing, but we are going to cover it in this lecture, so don't worry about it. Cool? So we have numbers 1 through 5, and I'm going to specify it as type number, and then I'm going to provide the array syntax. And as soon as I do that, now we should not be able to provide a string. And it's the same thing. Type string is not assignable to type number. You already know what that error is. Cool. Let's save that, and we can actually console log it. And when you look at it in the browser, it's basically normal JavaScript array. There we go. It's this array. The prototype is array. We have all of these methods that are available, functions that are available on this array. It's normal JavaScript. Cool. So this is an array of numbers. I could say array of numbers. We can also create an array of strings. And I'm going to put that down below. I'm going to say array of strings. And I'm going to say let products, that is going to be an array of strings, is going to be equal to this. So the products could be anything that we want. I'm going to say hats, shirts, and jeans. Cool. Let me capitalize this S and capitalize this H. Let's save that. So as I hover on it, we can see we have the string. We cannot add 25 there because it doesn't. It is going to throw a type error. Cool. I'm going to bring this down. And we can also take a look at it in the browser. Console.log products. Let's save products. Okay. There is a U missing. There we go. And we can see it's a normal JavaScript array. So what if you want to create an array of numbers and strings? How would you do that? That is simple as well. I'm going to bring this down. So an array of strings and numbers. Why is the caps lock on? And numbers. For that, we are going to say let mix data. What we are going to do here is we are going to open up parentheses. So we want to have a string or a number for our array. Do you remember the logical OR operator in JavaScript? That was this logical OR operator, double pipe character. This is the logical OR operator, and then we have double ampersand, the logical AND operator, and this is the logical or the inequality operator. Remember these? So take a look at this. There are two pipe characters. It signifies this or this. You know that, right? But in TypeScript, the logical OR operator is just simply one pipe character. So we are going to say we want either a string in our array or a number. So unless you directly specify it like this, you annotate your arrays like this, you will not be able to add numbers in a string array or vice versa. So now this string is able to accept hi string, 25 a number, hello a string. So you can see there, even though it says string and number, and or number, we can add more than one string because of this OR operator. It says or this, but technically this is not the OR operator. This is the union type in TypeScript, but we have not actually gotten to that part, and I want to make this easy on you because if you have a lot of experience in JavaScript, I'm going to be honest with you, there's going to be a lot of times where you might think, what am I even doing here? Why am I even trying to learn something that I've already learned? I've already spent so much time learning, and that is JavaScript. Why do I have to learn TypeScript when I know JavaScript? So there is going to be a lot of those moments when you are trying to learn TypeScript. And what I wanted to do more, focus more on this course, was this aspect, this very aspect that I don't want to give you any reason not to use TypeScript, because once you get used to TypeScript, you will never go back to using JavaScript. Your code is always going to be in TypeScript. That's why I'm easing you in to this world of TypeScript. I don't want to scare you away, and I don't want to give you reasons to not learn TypeScript. Okay, there is like a lot of jargons that I could have talked about, but I didn't because I don't want to scare you away. Cool. This is, again, this is basically a union type. We are going to talk about that in our upcoming sections. We have a lot to talk about. There is like a ton when it comes to TypeScript because it's a programming language. Even though it runs JavaScript code, it is a programming language, so you need to keep that in mind. Cool. We can take a look at this mix data, and it will look like a normal JavaScript array. We can also model this into something that would accept booleans as well. And for that, I'm going to copy this down below, and I'm going to say mix data 1, and I'm going to name this mix data 2. Let's put it there, and booleans. Let's get rid of this. Not grammatically correct. And for this one, we are going to do the same thing. Union operator or boolean. So boolean. And as soon as I do that and I save it, we can see we got the same array, but now we can add true or false into that array. There we go. So it says hi, 25, hello, and then true. And you can add as many other values that you want within here, and you can see the compiled JavaScript code as well, and this is going to be readable to you, right? This is the code that we're talking about. We can also take all of this to the next level, and what I would like to do is I would like to comment out the console logs, because now we're actually diving more and more into the realm of TypeScript. Now what if I ask you to go ahead and create a nested array in TypeScript? How would you do that? So everything, I'm going to say nested number type array. Everything we have learned so far is not going to help us. Why? So let's say I have my nums, my numbers, and I'm going to say this is an array with a type of number. And I'm going to grab our array, and let's say I want to provide another array here, and then this is a nested array, arrays of an array. Within here, I'm going to say 1 and 2, and within here, I'm going to say 2 and 3. Clearly, we have two errors, and it says type number is not assignable to type number. Now, what is actually happening here? You're having a nested array of arrays. This syntax only represents an array. It doesn't represent a nested array. So if you want to accept nested arrays, you need to provide another syntax, another pair of curly brackets. Sorry, these are not curly brackets, square brackets. And now you can see right here in the JavaScript, we have let nums 1, 2, and 3, 4. And let's add 25 there. It is not going to add it. Why? Because you have specifically specified that this array, this mynums array, is only going to accept other arrays. And those arrays can only be of type number. And you can see how specific TypeScript can get, and that's actually a good thing. So this is how you can create a nested number type array. We can console log it as well, so you can see it in the browser, my nums. And there we go. So we got two arrays each of them is going to be one item of the array. Cool. We can also create a nested string type array with TypeScript as well. I'm going to get rid of this console log. You don't really need it. This is going to be string, and we're going to follow the same thing. Let my, I don't know, like strings. It's going to be string, and then since I want to have a nested array, I'm going to do that. So in here, I can't say like hi. Why? Because this is not a nested array. But as soon as I wrap this with square brackets, it's going to work. And there we go. This is what we got. So you could say hi, and then it could be of, okay, where did it go? It could be, I don't know, like hello, and then I could say there. But the length doesn't matter either. So it could be like one item within an array, as long as they're actually surrounded by square brackets, it means that it is an array and it passes this test. Now, what if you want to create a nested array of a number and a string? How would you go about creating that? And I'm going to give you 3 seconds to pause the video and create a nested array of type string and number. And after 3 seconds, hit the play button again, and I'm going to show you how you can do that. All right, how is it? I'm sure you figured that out. We're going to use that logical OR operator or the union type. And this is going to be nested string and number type array. And I'm going to copy this one and I'm going to put it down here. We are going to change its name to mix data nested. Cool. And now this specifically says that it is a string, but we're going to surround it by parentheses, add that union type, and then we are going to say number. And now we can only create nested arrays of either type string or type number. So at the start, what I would like to do is I would like to create one, this is going to be 1 and 2, and I'm going to save that. There we go. So what do we have? We have 1, 2 right here, and then we have hi, then we have hello there. It doesn't matter what the length is. It could be 3, 4, 5, 6, 7, 8, 9, whatever. It could be any length. And when we take a look at it, it is actually accepted by TypeScript. We can log it to the console as well. That is going to say mix data nested. And there we go. We got an array that the first one has 9 elements, 1 element, and then we have 2 elements. There we go. Tuples are another data type in TypeScript. They're actually fixed length array, and they are written like this, like the actual name is tuple. You could call it tuple. You could call it tuple. I believe you could also say tuple, I think. And in vanilla JavaScript, we don't have tuples. And I'm going to be calling it tuples because I think that sounds better. But we do have tuples in TypeScript. And tuples, again, are fixed value or fixed length arrays. It means once you fix the length of that tuple, you cannot increase the number of values assigned to that tuple or decrease it. It has to be that fixed length. And when we compile a tuple to JavaScript, it's going to be like a good old-fashioned regular array. Let's create our very first tuple, and I'm going to say const course details, and I'm going to specify it. So within this tuple, the syntax of tuple is going to be similar to the syntax of an array, but the type annotation is going to be different. For an array, we had that type of that variables, type of the values that we wanted within the array, and then we put this pair of square brackets next to it, next to that value of type of values. But in here, we just have that. And within here, we are going to specify that the first value has to be a string and the second value has to be a number. And that's it. So the first value is going to be string, CSS, let's say my other course, layouts, master class. And the other one is going to be a number. And that's going to be 84.99. And that's it. So as soon as I hover on this, you can see that this is the type of a tuple. This is what a tuple looks. But in JavaScript, this is like a regular good old-fashioned array. How can we take a look at that? Console.log course details. So in TypeScript, we created a tuple, but as soon as we compile it to JavaScript, because again, TypeScript cannot be understood by the browser. So if this TypeScript would to go directly to the browser would have no idea what the heck is going on here? So it takes a look at the JavaScript. The JavaScript says, I don't know what a tuple is. I'm just gonna take a look at this. I haven't even heard of it. And the TypeScript compiler says, okay, I know what that is. That is basically an array of fixed length. And I'm gonna convert it into an array. And right here you can see that it is basically an array. But in TypeScript, it is actually a tuple. I'm going to zoom out a little bit, and you can add more values to a tuple. For example, like 12, you can do that. And as soon as you do that, it says type string number. What does that mean? It means this CSS layouts master class is string. This is number and this is number. So type string number, and number is not assignable to type string and number. That's what it basically says. And also says source has 3 elements, but target allows only 2. You can see target allows only 2. So we can do that. And we can even add it at the start of there. So I could say 12 hyphen that, and I'm going to get rid of this. We can't do that either. Why? Because it says type number is not assignable to type string. And you might be thinking, okay, why is it saying that? Because clearly we are saying that we want to type string and we want to type number. Well, the reason that it is saying that, it is because these values are not in the right order. First one has to be a string and the second one has to be a number. And yes, that's how strict TypeScript can get. TypeScript can get even stricter than this. And believe me, that is a good thing. If you have run into JavaScript bugs before. So the first value is a string, so we need to pass in a string. That's why it says, because this is a number, it's not assignable to string, and because this is a string, it's not assignable to a number. And another reason is that we're not using that or operator. We're not saying this or this. We are saying this, and it has to be this. It must be this. Cool. I'm going to put everything back, and there we go. Now, there is a cool thing in TypeScript. I'm going to comment this one out, copy it down below, and I'm going to save that. Let's get rid of all of this annotation, and I'm going to save it. Again, we are going to get the same array in JavaScript. That is not the point. The point is, what do you think is going to be the type that has been inferred by TypeScript? Type inference happens when we do not explicitly annotate the type of our variables. Like in this example, we have explicitly annotated the type, but in here we have not annotated the type explicitly. This is called type inference. It means TypeScript is going to infer a type for us. What do you think that type is? It is going to infer a type array for us. And if I take a look at it, there we go. This syntax is familiar to you. So if you're thinking that you want to create a tuple, and you're just going to provide like a by data value, and you're going to let TypeScript infer that, I mean, it's not going to work. You need to explicitly specify what it is that you want to create. And that's the good thing about TypeScript, that it tells you that it wants you to specify the type. It wants you to know exactly what variable you're using and why you are using that variable. If you don't know the type, probably you don't need that variable. And this is how you can start to create applications that matter. You can start to create applications that are really, really high level and professional. Cool. So by default, the type annotation is going to be an array. I just wanted to talk about that as well. Now, this is this tuple is good for a by data value. It means like there are 2 values and both of them are of different types. I mean, if you want more values, you can always use a regular array. All right, let's talk about another built-in TypeScript type. In this video, I would like to talk about enums. Enums allow us to declare a set of named constants. A set of named constants basically means that we have a collection of related values that could be numeric or string values. We have 3 types of enums. We have numeric enum, string enum, and we have heterogeneous enum. Let's talk about all of them in this video. First off, I would like to talk about numeric enums. Enums are created using the keyword enum. So enum, and the name for an enum has to be Pascal case. A Pascal case is like this. So we have Pascal case. It looks almost like the JavaScript camel casing, except that the first letter is also capital. In JavaScript, except for the first word, all the other words for an identifier, their first letter has to be capital. But in Pascal, that first word's first letter also has to be capital. So this is Pascal case, and this is camel case in JavaScript. You can see the difference. The C is not capital, but this is capital. So these two are, I'm just going to leave them there. Let's say we have roll numbers. Now you can see the Pascal case in action. We want to create an enum. It looks like an object, but it is actually an enum. And we are going to take a look at the JavaScript transpiled code as well. And you're going to see why we are going to use enums, why we need to use enums in TypeScript. So I have a student called John, another one called Kelly, and then we have Sandra, Joseph, cool. And finally we have Samantha. And I'm going to save this. And as soon as I save it, you can take a look at all of this code that we have in our JavaScript. So we have a lot of crazy stuff, and all of this code is here to basically give us roll numbers from 0, 1, 2, 3, and 4. So the first student is going to have a roll number of 0, then all the way to Samantha, which is going to have a roll number of 4. We can take a look at these in the browser. So console.log. Roll numbers. Let's save that. There we go. So we got an object, 0, John, 1, Kelly, 2, Sandra, and so on and so forth. Now it gives us a lot of stuff when it comes to JavaScript. Now I'm not going to try to decipher this because we are going to get rid of all of that. Don't worry about it. Now these roll numbers, they start from 0. What if we want them to start from 1? So in that case, I would just go ahead. You know what? I'm just going to copy this and comment it out so you have the code as reference. I'm going to paste it here. I'm going to say that John's roll number is going to start from 1. And now you can see it says 1, 2, 3, and all the way to 5. Now, if you want to get rid of all of this nonsense that we have within the JavaScript, the only thing that we need to add is the const keyword. That is going to simplify all of this process for us. Let's save that, and there we go. And now, so far, we don't see anything in the console. Why? I keep saying console, in the JavaScript. Why? Because the JavaScript doesn't have this. We haven't done anything with this. So let's say I want to access the value for the roll number of Sandra. Let's say that this list is 10,000 long. What is the roll number for Sandra? I don't have the time to count it. So I'm going to say console.log. And you know what? Before actually console logging it, let's actually save it. So I'm going to remove that space. Let student list. Now, within here, as a type annotation, what do you think I should provide here? I mean, should I provide a number? I mean, we are going to get a roll number. Should I provide a string because we are getting the roll number for a name, or what? What should I provide? I'm going to give you like a couple of seconds to pause the video, think about it, and I'm going to give you the answer. Now, remember at the start of this video, I told you that enum is another built-in type. Keep in mind, the name of this lecture is type, enum type. So enum is a type. This type is the same, is a type, the same as a number is a type, string is a type, Boolean is a type, roll numbers is another type. It just happens to be a type that we have created manually. It's not a built-in JavaScript type, but it is a built-in TypeScript type because it is an enum. So I'm going to set that to this roll numbers. since roll numbers, it refers to an enum type, we can specify our variables. We can type annotated to this type. Cool. So far, everything is making sense. And I'm going to say from roll numbers, I want to grab the roll number for Sandra. Remember? And now I'm going to pass in this student list within the console. And now you can see within the JavaScript, since we have used this const keyword, we don't have any kind of mumbo jumbo. We just have a student list that is equal to 3. And then we have that student list console log that shows 3. But in the TypeScript, we actually have 5 names. We can select, let's say, the roll number for, I could change this student list to something else. Student roll number 1. It's a little bit longer, but it conveys the point. This is going to be 2. And let's grab the Samantha's. And as soon as I do the dot operator, you can see we got all the members of this roll number type, roll numbers enum type. We got all of the members. So let's grab the Samantha. And what did I do here? What am I doing? Let's put, oh, it's Persian. Save that and let's change it to 2. And now in JavaScript, we don't have anything. We don't have this info that this 3 is actually a roll number for Sandra and this 5 is roll number for Samantha. And now you can see how more efficient TypeScript is. We have a lot of stuff in TypeScript that don't actually compile back to JavaScript. That is cool, right? Everything is making sense so far. Now, this was everything you need to do. You need to know about numeric enum types. Let's talk about string enum types. String enum types, or string types for enums. We can create an enum using const. We know that. So I'm going to say this is an enum. What is the name of the enum? I'm going to say student details. Everything is making sense now. I'm going to say the student details is going to have a name. That is going to be John. And it's also going to have, we are going to use an equality sign there. And we're going to have a major. This is not an object. Keep that in mind. That's why we're using equality sign. The major could be arts. Very well. How can we access these values? We can say let student name. Now, what is the type of this? The type is that student details. We're not, even though we are accessing strings, we're not going to say string because the type of this is actually this enum type. I talked about that. And this is going to be student details. And as soon as I do dot, we're going to get the name. And from here, I'm going to get the major. Let's do major. We can console save that. See it within the JavaScript, and we can log it to the console as well. I'm going to say student name as well as student major. Let's say both of them, John, and then the major is arts. It's not like the last name, John Arts. No, John with a arts. And we can also have heterogeneous enums, which means that we could use a type of string with a type of number. And I'm going to create a heterogeneous enum for you right now so you can have an idea. Heterogeneous, I think heterogeneous enums. And for that, I'm gonna be using the same example. You know what? I'm even going to copy paste this entire thing. Let's copy it. Let's put it right here. And I'm going to comment all of this out because there isn't actually much that I'm going to change here. And I'm going to say, let's add an ID to this student. I'm going to say ID is equal to 1. And let's add the comma. Everything is cool, right? And I'm going to say, this is the student ID. And I'm going to change this. I could have done Control D. And let's save that. Let's do a template literal. and I'm going to grab that value. And there's a dollar sign. So student ID, and then we are going to grab student name has a major in, I think. Is that the correct sentence? Let's just worry about the programming of it. Student major. Save that. Very good. So this is the ID. One, John has a major in arts. That's it for this video. See you in the next one.
Hi everyone, welcome to this section. In this section, we're going to take a look at some basic implementations of conditionals and loops in TypeScript. Specifically, we are going to talk about if statements, we are going to talk about for loops, for of loops, and for in loops. Now, some of these concepts are going to be newer JavaScript, and they're going to be a really good place for you to actually practice modern and cutting-edge JavaScript.
I am sure you already know how an if statement works in JavaScript. In this lecture, I'm going to show you how TypeScript adopts JavaScript's conditionals. So first things first, I'm going to go ahead and I'm going to create 3 variables. The first one is going to be num1, and I'm going to assign 10 to it. Now, this is a variable that is supposed to hold a number. So what I'm going to do is I'm going to type annotate it to number. This is the proper way of doing it. And I'm going to create 2 more variables. The second one is going to say num2. Third one is going to say num3. Very basic stuff so far. And for the final one, I'm just going to do 15. Now, the conditionals, aside from type annotating values, it's the same thing that we had in JS. We have the same thing in TS or TypeScript. And the idea behind these lectures is just to get you more familiar with all of these types, like give you a little bit more practice. Now, we can check for a single condition, and we can do that. We are going to say if num1 is greater than num2, then perhaps we would want to print something on the screen. So I'm going to say console.log. Let's put the E back here. I could use template strings, and I'm going to say num1 is greater than, let's put that back here. It's greater than num2. If num1 is greater than num2. Let's save that. And we can see 10 is greater than 5. We can check for 2 conditions if we want. In that case, we are going to say if num1 is greater than num2. Very simple examples. And then what do I want to do? I'm just going to basically copy this line, put it right here. And then I'm going to say else. Else says if num2 is greater than num1. Then I'm going to say num2 is greater than num1. Let's save that. Or I could just say num1 is less than num2. There we go. So 10 is greater than num5. The first one comes from here. Let me comment this one out. And in case I go ahead and I set this to 25, now you can see it says 10 is less than 25. Cool. Everything is okay so far. This is when we want to check for 2 conditions. We can also check for multiple conditions. And for that, I'm just going to modify this one and comment it. If num1 is greater than num2, I'm going to print num1 is greater than num2. Let me just bring this JS down a little. So if I want to check for multiple conditions, the second one would be else if num2, or I could just say num1 is less than num2, then print this one. We could also check for num3 as well. Let's do that. I'm going to copy all of that, put it right here. Else num1 is greater than num3. Come on, buddy. We are going to say num1 is greater than num3. Cool. What is the other else if? Let me copy that, put it right here. If num3 is less than, let me get rid of that. Then I'm going to say less than. So this is else if. We don't have an else statement. I'm going to get to that just like a couple of minutes. So if num1 is greater than num2, then we have else if, then another one, and then another one. So in any condition, if one of these if statements, one of these blocks returns true, then the other block is not going to run. Now, there is an issue with this code. There are several issues, but the main issue with this code is that we are checking this num1 against num2, and we're also checking it against num3. Now, the scenario for num1 and num2 should be separate from the scenario with num1 and num3. These two are completely different because here we have num2, here we have num3. But the issue is that if this returns true, this conditional right here, this code is going to run. And we are not going to even consider checking for num1 and num3. So what we need to do is we need to separate this. We need to refactor this code a little bit so it's better readable. You can see it's not that readable. And it actually performs the logic that we want it to. Therefore, what I would like to do is I would like to get rid, cut all of that, and I'm going to change this back to just an else statement, and I'm going to get rid of this as well. So that's one block, and then I'm going to put the other one down here. I'm going to get rid of this else, and I'm going to get rid of this if along with the conditional, and there we go. So now we have two different conditionals because in each set of these conditionals, we're checking for something different. Here we have num1 and num2. Here we have num1 and num3. These two have to be separate from one another. And now you can see we got two console logs. One is against num2. The other one is against num3. Now, we could also simplify this using a ternary operator. And we could basically say, I could just comment everything out, and I'm going to show you how you can do that. So we are checking if num1 is greater than num2. Why don't I copy that, put it right here? So if this is true, then what do I want to do? Whatever I want to do, I'm going to put it after the question mark. So if num1 is greater than num2, I want to do this. If it is not true, then I want to do this. Cool? Very simple stuff. This is a ternary operator. We get the same result, but a lot less lines, a lot of less if statements, this and that. We can do the same thing for num1 and num3. I could just copy this down below. I'm going to change this to wherever we have 2, I'm going to change it to 3. There we go. So now we got the same result. And I think that's it. That's it for this lecture. See you in the next one. For loops are going to work in TypeScript the same way as they do in JavaScript. The only thing that we would want to add would be that type annotation. And that's very simple. So I'm just going to give you a very simple example of a for loop. This is for let I is equal to number. Now we could leave this as it is because the type is the TypeScript could infer the type as number. Let me just complete this, and I'm going to say I is going to go all the way to less than 10, and we're going to increment I by 1 in each iteration. And then what I could do is I could just say console.log. Let's grab the value of I. Let's save that. There we go. And these are the values of I. Now, if I hover on this, you can see the TypeScript, it infers the type as number. And here is the JavaScript representation of it. But we could also explicitly annotate the type as number. And that's it. There is not going to be any difference. And there is nothing else you need to know here. It's just an example of a simple for loop that has been converted into type annotations of TypeScript. Now I'm going to save that. We can see we don't have anything in JavaScript because comments are not allowed to pass. I'm going to give you a little bit of a better example. Let's say we have an array of nums. How would you create an array? Remember, we would always put the bracket notation for the array, and then we would specify what kind of data the array would accept. This is going to be an array of numbers. I'm going to say 10, 20, 30, 40, 50, 60, 70, I forgot to do the commas. There we go. Let's save that. Cool. Now this is an array of numbers. We could say, let's iterate through it and get all the numbers. I'm going to say I, that has a type of number. We clearly can see that it is a type of number. It starts from 0. Now we want the iterations of this for loop to continue for as many items there are within our array. And we don't want to count them manually. We want this to happen programmatically. So I'm going to say I is less than nums.length. This length is going to give me how many items there are. It's going to go all the way to less than that. And then we are going to increment I. Let's grab console.log I. This is going to give us the indices for all the items. And we could also get the item itself. And I'm going to put that num right here. And this is going to give us all the items. Nums. Save that. There we go. So we got 10 all the way to 70. That's everything there is to know. See you in the next video. All right, let's talk about for-of loops. In case you're not familiar with for-of loops, there are a newer way of iterating through loops in JavaScript, and they are also available in TypeScript. And they actually simplify all the confusion that arises with by using just regular for loops. And I'm going to show you an example of that. So you can see within this JavaScript, this compiled code, we can see we have this I variable that we need to keep track of, that we need to increment, and we need to make sure that it does all of this just so we can log something. We can iterate through a numbers array. And then we need to grab the original array and pass it as an index so we can get to see our the items of the array. And the TypeScript syntax doesn't even simplify this, and it adds something else, and that is type annotation, which is I is number. Now this syntax could very easily confuse beginner developers. There's a lot of going on, and if you have nested loops, then that's just unreadable. For-of loops, if you're not familiar with them, they are the kind of loops that can iterate over any iterable. An iterable is something that can be countable, that can be counted. So an array, you can count, okay, it has 1 item, 2 items, 3 items. It can iterate through it technically. That is not actually the proper definition of an iterable with a countable. That is something that I tell my students just to give you like a mental model of what an iterable might be. Array is an iterable, and we are going to use for-of loop to iterate over an array. I'm going to create that array, and you're going to see how simple, so much simpler it is if we just use the for-of loop. And let's type annotate this as string and number. It's a good practice. And then I'm going to say, let's add Cosmos, the number 13, the number 50, and the string star. This is our array. Cool. Everything is cool. Now, how are we going to iterate through this using a for-of loop? The first thing is the for keyword. You need to make sure that you first understand the syntax. This is the syntax of for-of loop, and this is the block. That's it. So within the parentheses, we are going to say let. Now, this is going to be like initiating that, initializing that loop variable, like let I equal 0. It's like that. But instead of saying equal 0, we are going to say entry. So this entry, you could say I, if you are more like comfortable with just writing I. But using for loops, I like to be a little bit more specific. So every item, every array has several entries or items. I could just say item. And then of what? Of mixed data. And that's it. That's the only thing you need to do. You don't need to pass in a condition to avoid running into infinite loops. You don't need to increment the loop variable to count for the next iteration. And you don't need to do anything else. You just have to say for let item. Now, this item is the loop agent. This is going to grab one item in each iteration, one item from this array. And what do we want to do with that? It's going to store it within the item itself. We can just say item, and it's going to give us all of that. Very cool, very simple. Now, if you want to access the index of these items, you can do that as well. There is a method that is called .entries, and this is going to give you like a pair of the index as well as the item. And you can extract the index from here as well. So we can see that we got this array right here. The first item of these arrays is just the index, and the second item within these arrays is the actual array item from mixed data, the actual data that we have. So we could easily say, give us the first one, this is going to give us the indices, and we could also say item 1, and this is going to give us all the items there. Now, there is another cool way that we can use, that we can work with for of loops, and that is we can destructure arrays. Now, destructuring, again, is a newer syntax in modern JavaScript. I am actually, I do have a tutorial series on YouTube, and there is, I've actually talked about modern JavaScript ES6 and beyond. You can take a look at that if you want. And you're going to get familiar with all of these new features, new and exciting features that have come out in this past several years for JavaScript. So what I'm going to do is I'm going to destructure the, instead of doing this, we can do better. I'm going to destructure the index as we are iterating through the array. And destructuring of an array basically means that we grab this array and we pull it apart. That is what destructuring means. So the destructuring syntax for an array is a pair of square brackets. We also have destructuring for objects, but for that, it is a pair of curly braces or curly brackets. So I want to grab the item as well as the index. And the index, I'm going to specify it as I. And instead of saying this, I could just use backticks. I'm going to do the item is hyphen the index of the item hyphen the item itself. And as soon as I save it, you can see we got a more readable output on the console. But you would say, okay, I don't want it to start from 0. In that case, you just have to offset it by 1. And it's going to start from 1 all the way to 4. For in loops are used to return the index of items from an array or from a tuple. We recently talked about for of loops. In this lecture, I want to talk about for in loops. And for in loops are programmed in a way, are designed in a way that are going to get us the indices first. And then we need to do a little bit of extra work to get the actual item from an array. And I thought, okay, you have to know how for in loops work. You might not want to do all of that work that we did in our previous lecture to extract the indices. Even though we did destructuring, we used destructuring, which is a modern method, modern way of doing things. But it's a good idea to learn for in loops in case there is a need to use them. I'm going to create a loop, create an array, and this is going to have type of number and string data. And this array is going to be, it's basically the same array that we had before. Cosmos, and then I'm going to add 13, 50, and then star. Save that, there we go. Now the syntax for in and for of is almost the same except for that in and of. Let entry. In this case, I'm going to do data point. Cool. Data point. In instead of, I'm going to say in data. Let's take a look at what this data point actually is. And for this one, I would like to create our block, console log, data point. Give me the data point. And we can see we got 0, 1, 2, 3. And you might notice that this is like, this is white. Why is this white? And we know that when we print numbers on the console, usually they're blue, they're not white. So what is the type of this? I'm going to comment this one out, put it down below. what is the type of all of this? And if you take a look at the type, you can see we got string. So it does give us the indices, but it gives us strings. So now we have to do something else to convert them into numbers. Now, there is actually something very, very simple that you can do in JavaScript. In JavaScript, we have something called a unary plus operator. The job of a unary plus operator, which is basically a plus sign, is that it is going to convert a string into a number. Very simple. So it's the same as using the parse int or parse float method. These two are the same. So I'm just going to do it like that. Cool. Maybe not like that, maybe like this. So now that we know that we got strings, if I just copy that down below, and if I just add a plus sign, now we got numbers. And I'm going to comment that one out, get rid of the comment from here as well. And now we should see 4 numbers. There we go. Very cool stuff. Now, this is index. You might be thinking, okay, I want the index, and I also want to grab the array items. How would I go about doing that? Well, you need to do what we did for our regular for loops. So I'm going to say console.log. And let's use our template literals. I'm going to say data point. We are going to offset it by 1. We are going to take a look at that. You know what? I'm not going to offset it. I'm going to add it later in like a couple of seconds, so you can really see what the issue is. I'm going to grab our array, and then I'm going to pass in data point, because data point is actually an index. This index is iterating through this array. Let's save that. There we go. So we got 0, we got 1, and then we got 2 and 3. And now we did offset our index in our previous lecture. Let's offset it here as well, and let's see what is happening. Whoops. What is happening? It looks like we got 0, 1, 11, 21, 31. This is not the right way of doing stuff. Why? This is actually data point is a string, and it's like we're adding a number to a string, and when you want to add a number to a string, it's basically going to put both of them side by side. And the only thing that we need to do here is just add a plus sign there. The reason that I'm adding these step by step is so you're not confused. Okay, what is this plus sign? What is this plus sign? Now you know what each one of them means. And now you can see it says 1, 2, 3, and 4 the way you want it to.
Hi everyone, welcome to this section. This section is going to be the first part of the Let's Get You Coding Challenges series. The aim behind this series as a general is to get you coding challenges, and that's as simple as it is. So the way that I've arranged these challenges is that I'm going to be showing you the solutions on the whiteboard behind me. If you go ahead and download the resource files for this section, the part 1 of Let's Get You Coding Challenges series, you're going to see that there is like a lot of files. Most of the files are going to be solution files. Some of them are going to be challenges files. Now, depending on the concept that we have studied before, like in preceding sections, there is going to be several challenges, one or more than one challenge for that specific concept. For example, what we're going to start this section with is going to be basic types. So for basic types, you might have one challenge, you might have 2 challenges, depending on the need of the topic, depending on the difficulty level of the topic. I've included several challenges. And all the challenges, they are listed in one file. And that file's name is, for example, basic types challenges, where you're going to see all the challenges, and you're going to have all the info that you will need in order to solve those challenges. So if you see, for example, like 5 challenges for a specific concept, 5 challenge solution files, it means that concept has 5 challenges. And that's how we are going to go. We are going to go and move forward. So I think that is everything I wanted to talk about, and see you in the next video. Hi everyone, welcome to the first challenges solution. This is the first challenge for the basic types, and the requirement for this challenge, the challenge statement is that create a variable with the type number, and assign it an arbitrary value. So what I'm going to do is I'm going to create a variable with the type number. Now, we have talked about how we create that. First, we are going to decide whether or not we want to use let or const. I am going to use let for this specific example. So I'm going to say let. Now, the name of the variable, it could be arbitrary, whatever it is. So I'm going to say score. Now, typically what we would do in JavaScript is that is it. And then we use the assignment operator, and then we assign it to an arbitrary value, whatever value that we want to assign it to. In this case, I'm just going to assign it to 19. Now, what is the type of this 19? We know that 19 is of type number. Therefore, in TypeScript, we are required to type annotate our variables. So 19 is of type number. I'm going to add in front of this score a colon, and then I'm going to say number. And that's it. That is the solution to this challenge. See you in the next one. Hi everyone, welcome to your second challenge's solution. This challenge states that we need to create a variable with the type string, so type annotation is going to be string, and we need to use the addition operator to put two arbitrary words together. Let's go ahead and let's actually solve this. The first thing that we need to decide is which keyword do we want to use. Do we want to create a variable with let, or do we want to create that with const? I am going to create that with let, so this is let. Now, I'm going to call the identifier for this, doesn't really matter, I'm just going to call it my name. Pay attention to camel casing. And then we need to type annotate it. And the challenge says that we need to type annotate it to string. Whatever we type annotate an identifier to, it has to be a valid data type. And using the plus operator, I'm going to say Muslim plus, and I could add like a space here, and then I'm going to say Hilali. And that's it. That is the solution of this challenge. See you in the next one. Hi everyone, welcome to your third challenge for basic types. This challenge says that we need to simulate a type error by assigning a number to a string. Let's simulate that. Now, you might be thinking, why is this important? Why do we have to simulate a type error? Isn't that something that we are actively trying to avoid? Yes, that is something that we are actively trying to run away from, especially when we are trying to learn TypeScript and you're trying to understand how TypeScript works. But a type error or a compilation error is at the core of TypeScript. If you want to be able to debug your application's issues and bugs, you need to be able to know the exact anatomy of any kind of type error that you might have. So it is very important to write some bad code so you can point out what are the issues with that code, and then you can fix it. So it's really important for you, for the learning process and getting used to paying attention to TypeScript. Now, if you have a lot of experience with JavaScript, this is going to seem a lot of work, but trust me, it is going to be worth it. That's why I'm emphasizing so much on these exercises, because I want you to get the entire idea of why we are trying to learn TypeScript. So let's jump back to this challenge. So we need to assign a number to strings so we can simulate a type error. Now, what I'm going to do is I'm going to use let again. And this variable, it could be anything. And I'm going to name it, we could name it size. This is lowercase s. And I'm going to type annotate this size identifier to string. So the type of size is string. Now, when the type of size is string, the only value, the only data type that it can accept is a string. It cannot accept a number. Now, as soon as you do this, what you have actually done is that this is going to throw a compilation error saying type number is not assignable to type string. That is the solution. See you in the next video. Hi everyone, welcome to the fourth challenge for basic types. The statement for this challenge says that we need to create a variable with the type Boolean, so we know that the type of the variable is going to be Boolean, and assign it to the logical OR operator comparing two values. Now there is going to be a tricky part to this solution, and we are going to get to that, and when we do, I'm going to explain that. First off, we need to specify what kind of keyword we're going to use to create this variable. I'm going to use the let keyword. The name of this variable or the identifier is going to be passed. Now, we need to type annotate it to type Boolean. That is what the challenge requires. So it is of type Boolean. And as soon as we type annotate it to type of Boolean, we cannot store within this identifier any variable or any value that is not of type Boolean. We can just store Boolean values in this variable, and we need to write the OR operator that is comparing two values. Now, as soon as we do this, we can see that what is going to be on the left side of this OR operator and what is going to be on the right side. That is what the Boolean type annotation is going to tell us. And that is the tricky part. So if you thought that you could just write here 1 and you could write here 2, that is going to be a compilation error saying type number is not assignable to type Boolean. So that is a no-go. And you cannot use strings either. You can't say like a string of 2, or rather like this, is going to be equal to Boolean. Why? Because this is a string. It is not type safe. So the only values that we can use technically are true and false, since only Boolean values are going to be true and false. Now for the solution, it's going to be true and false, but that is just one solution. You could say true and true, and it wouldn't matter. You could say false and false. You could also say false and true. And all these solutions are going to work perfectly fine. So that's it for this challenge. See you in the next one. Hi everyone, welcome to your fifth challenge. In this challenge, the requirement is to simulate a type error by assigning a number to a Boolean. So let's go ahead and let's see how we can simulate another type error. Now, keep in mind, we are trying to assign a number, and you should know that when you're trying to assign something that is the right-hand side to a Boolean, which is going to be the left-hand side, this is how you know which side is which. So we are going to say let. Now again, the variable name is going to be completely arbitrary. So in this case, I'm just going to use failed, and we need to type annotate it to Boolean, since we are assigning a number to a Boolean. And there we go. So what is going to be the number? Whatever you want. In this case, it appears that I've written 15. So as soon as you do that, there is going to be a red squiggly line under this failed that is going to tell you that type number is not assignable to type Boolean. And that is how you simulate a type error. That's it for this video. See you in the next one. Hi everyone, welcome to your sixth challenge. The statement for this challenge says, get the length of an arbitrary string. So let's go ahead and let's do that. So for this one, what I would like to do is, I would like to create a string. First, we need to decide what is going to be the keyword that is going to create a variable for us, which in this case is going to be let. What is going to be the identifier? The identifier is going to be language. So I'm just going to say language, and we need to type annotate. Now the statement says arbitrary length get the length of an arbitrary string. That is where the magic lies. So we know that it is of type string. So we are type annotating it to string, and then we need to basically get the type of it. Now in this case, I'm just going to write TypeScript, and don't forget to get the length. Now, another good thing about type annotation is that whenever you type annotate any identifier and you do the dot operator, like this one, or maybe like bigger so you can really see it, as soon as you do the dot operator, all the methods and properties that are available on strings, they are going to pop up right here in the IntelliSense, and it's going to show you everything. So in that way, that is going to be like one way of type checking, that you know for sure that the variable that you've created has a type of string, since you can only see the string properties and methods. Now in this case, we are not worried about anything else. We just want to get the length of it. And this is how you get the length. And that is it for this challenge. See you in the next one. Hi everyone, welcome to your very first challenge for inference. The statement for the first challenge states that assign a number to a variable with no type annotation. What is the variable type inferred by TypeScript? Now that is very difficult to show you what the inferred type actually going to be, like showing that to you, but I can explain to you what that is going to be. So first off, let's create a variable and assign a number to it, and no type annotation, like simple JavaScript. So I'm going to say let number, and I'm going to assign to it a value of 31. Now there is something in TypeScript that is called inference. Inference in TypeScript comes into the picture whenever you create a variable, or you create a function, or you create an object, or you create a class, and you do not type annotate that. So you're not specifically telling TypeScript what the type is. Now, TypeScript, being its nature to type annotate everything, is going to take a look at the value, the nature of the value that specific identifier stores. And when it sees a number, it is going to type annotate it automatically to a number. When it sees a string, it's going to type annotate this identifier as a string. And it might be tempting not to use type annotation at all, because you're thinking, okay, why should I go through the extra trouble with TypeScript? I mean, I'm going to use TypeScript, but I'm not going to type annotate anything. That is certainly one way to go. You could use TypeScript and not type annotate anything, and for the most part that is going to work well, except for like some cases which it's not going to work. And those cases is where TypeScript doesn't really know what the type is, and the inferred type is going to be incorrect most of the times in those situations. So it is tempting not to type annotate it at all, but it is actually considered a good practice. Now, if you're not type annotating these identifiers, then what is the point of using TypeScript at all? We're using TypeScript to type annotate everything, every variable, every function, anything that we can see in TypeScript that requires a type, whether that is the parameter type, argument type, function return type, classes, whatever. We are going to type annotate everything, because that is going to make our code more readable. That is why it's called a best practice. So when you're writing TypeScript and anyone else comes along and takes a look at this number, now this number, this identifier, is very self-explanatory. It clearly says that this is a number. Now imagine this was something else. This could be anything else. For example, if you have a product ID, or if you have like a grade, or you have a score, or you have a size. For example, you have a sizing system. So instead of saying number, I'm gonna keep this example right here, and I'm gonna say let size be equal to 3. And let's say you have a product line. You have size 1, size 2, size 3. Size 1 is small, size 2 is medium, size 3 is large. We are just going to keep it at that. And when you say size 3, this clearly says that it is a number based on this size. But what if you get rid of this number and you just set it to large? And now it's no longer a number, it is a string. So depending on what you want to do with your variable, the type of data is going to be different. Now imagine you have this size and you are conveniently letting TypeScript infer the type, and like after 50 lines, 100 lines, when you come to the size and you pass it, you assign it to a variable with the type of number, that is something that we have already done. You will be simulating a type error. And then you have to go through all of this code to see what it is that you have done incorrectly. But when you write it, okay, this size, it is of type string or it is of type number. You're correctly type annotating it, and hence you will be preventing further headache and further issues. So it is actually, again, a best practice to type annotate your variables. TypeScript is very good at inferring that. Not perfect, but good enough. However, that is not best practice. It is, if you don't know what the type is for this variable, for this identifier, chances are you don't need it. So whenever you're creating a variable, be that in JavaScript, be that in TypeScript or any other language, you should know what you want to do with that variable. If you don't know what that variable's job is, what it is storing, what you want to use that for, then chances are you don't actually need that. Or you have not actually analyzed the program requirements beforehand. So you're like creating variables and you're throwing them around, and at the end of the app you have like 100 variables and functions that you have not used, or maybe you could have just not used them and you could have basically used like anything else instead of that. So just make sure that this is, and in my opinion, this is a good thing. It makes you think. Now, what we usually do with JavaScript, especially with DOM manipulation, is that I've seen some people like whenever they want to create something dynamic, for example, like some hover effects with JavaScript or some animations or like that hamburger menu, clicking that, they try to select everything. And oftentimes they don't use half of those variables, half of whatever code it is that they've written. But TypeScript is not like that. TypeScript is different. That is why TypeScript is gaining more and more traction. It's gaining more and more fame. It has gained a lot of fame over the years. And that is why it's really important for you to actually understand what problems TypeScript aims to solve. One of the main issues with JavaScript is cannot read property of something. It can't read property of something. Now, that is because that thing is undefined or its value is never being read in the correct manner. Now, these kind of errors is something that JavaScript is, that TypeScript excels in preventing. So with TypeScript, you're not going to get those kind of errors. Now, even though this lecture was like very simple, it was like assign a number to a variable and see what the inferred type is. And by the way, if you want to see what the inferred type is, you just have to like hover on the number, and then there's going to be like a pop-up right here that is going to tell you after the colon, it's going to tell you number. It's okay for most of the part. But again, your code is not readable. Imagine you have 1,000 variables, 500 functions, whatever, like thousands of lines of code. And you don't type annotate anything and you get lazy. Now, when you want to get started with TypeScript and really master TypeScript, you should just avoid being lazy and not fully utilizing what TypeScript has to offer. You need to keep that in mind. TypeScript is a little bit more work, I accept that, but I'm okay with that because at the end of the day, the time that I'm going to put into debugging my application and pulling my hair out, it is better to actually put like 1/10 of that time that thought into creating my variables and creating my functions and type annotating everything correctly. And at any step in the application, if you make a mistake when it comes to type annotation, or you incorrectly assign a different type to something else, there is going to be an error. So it is better to start understanding what it is, what kind of data it is that you're working with. Now, it may seem like this data is very simple. It's very, very, very like forgettable and you could ignore this. But your application is basically based on these variables. You can't create an application without variables. This is at the heart of any programming language. That's why it's very, very important for you to master the variable creation. You have to master that. And when you master these, you're basically mastering fundamentals. And when you master fundamentals, it doesn't matter if you're in TypeScript. You can master it easily. You can jump into any other statically typed language like Java, C, C++, and you can master it right away. So I think that is it. The type annotation is going to be number, the same as with the identifier. I could just, instead of saying this number, I could just say this is score. In my solution, I just saw that I've written score. So that's it for this challenge. See you in the next one. Hi everyone, welcome to your second challenge solution for the inference section, inference part or concept. Let's start over. Hi everyone, welcome to the second challenge solution for the inference. And the statement says that we need to assign a string to a variable with no type annotation. And then we need to check what the inferred type is going to be. So assigning a string. Now the solution that I've written is going to be I'm going to have some sort of a book. Now my suggestion to you is it doesn't have anything with TypeScript, but it has everything to do with this book. Now I've read this perhaps like several years ago, and it is one of the best books that I've read. It is very, very good novel, so I do recommend you reading it. It's like it was when I had that hard copy, it was around 400 pages, but I think I finished that in like 3-4 days. That it was so interesting. Very, very good one. So the name of the book is, why am I changing color? And the mountains e-code. And there we go. So, and the mountains e-code is a string that we have assigned to the book. Now, if you hover, since you're typing in VS Code, or you have, let me just put this here, you have already done this. If you hover on this identifier, the type is going to be of type string. Again, that is not a good practice. You could do it technically, but it is best not to do it. Just go ahead and type annotate it to string, and that way you know exactly what the variable you're trying to work with is going to hold, what kind of data, and then just assign to it this and the mountains e-code. There we go. It is also in the resource files. So that's it for this challenge. See you in the next one. Hi everyone, welcome to your third challenge solution for inference. The statement for this challenge says that assign a Boolean false to a variable with no type annotation, and then see what the inferred type is going to be by TypeScript. We have already done like 2 of these challenges, and we're going to do the third one as well. First off, we're going to write the let keyword, since this is the keyword that is going to create a variable for us. The identifier for the variable, or the thing that we identify the variable with, is going to be passed, and we are going to assign the value of Boolean false to it. Now, as soon as we do that, something magically is going to happen, which is not something that you should do deliberately, and that is TypeScript is going to infer the type as Boolean. And if you hover on it, since you're following along on VS Code, if you hover on this pass, you're going to see that past colon type Boolean, the variable type Boolean. And I think that is it. That is it for this video. See you in the next one. Hi everyone. Welcome to your very first challenge solution for arrays. The statement for this challenge says create an array of numbers. Now, creating an array of numbers is going to have a different type annotation than creating an array of strings, creating an array of strings and numbers, creating an array of booleans and strings, and then so whatever data you want your array to hold, the type annotation is going to be different based on it. But for this specific example, challenge rather, we need to create an array of numbers and type annotate that correctly as well. So let's jump and let's do that. Let's say we have a variable called numbers, and then we need to type annotate this. Now I want to create an array of numbers. What is the array syntax? Syntax, not the actual keyword. Syntax for array in JavaScript is a pair of square brackets. This is the array syntax. What is the object syntax? This is, what is this? This is, I could never write this correctly. Neither in school nor in university, never. I always mess this up. So I don't know, like, did I do it like this? Yeah. In my previous course, CSS Layouts Masterclass, you know, CSS declaration block is like this, like an object. So I think I did it like that, yeah. So anyway, trip down the memory lane. This is the array syntax. We know that. The job of this is to create an array. But we are not in JavaScript. We are in TypeScript. Since we are in TypeScript, we need to specify what the syntax is going to hold. Is it going to hold a number, numbers, strings, booleans, whatever? So in this case, we want this to hold numbers. So we are going to say number. So what this means is that create an array, and then that array should only be able to accept numbers. Now it could accept one number, two number, infinite numbers. Technically it could accept that, all of them. And I'm going to assign it to, so first the syntax, and then the members or the population. So I'm going to do 1, 2, 3, what is that? 4, 5, 6, 7, 8, 9. I don't know why I keep going, but I do. So it's going to be 10. And again, we have a variable called numbers. The type of it is an array, and that array can only hold, in this specific case, numbers, and now it holds like numbers 1 through 10. So this is a correctly type annotated variable. That's it for this challenge. See you in the next one. Hi everyone, welcome to your second challenge for arrays. The statement for this challenge reads that from the previously created array, access the second indexed item. Now keep in mind, we are not accessing the second item, we are accessing the second indexed. The indices, since we know that from JavaScript, for arrays, they start from 0. So the first item has an index of 0. This has an index of 0, this has an index of 1, and this has an index of 2. How are we going to get that index? Now, a common way to grab the value from an array is using the bracket notation, and we can use that. And we could just log it to the console if we wanted to, and I'm going to do that. So I'm going to say console You weren't expecting to see console log even on a whiteboard, but here we are. So console.log. First, we need to access the or reference the array that we're trying to grab the second indexed item. It is the numbers array. So this is a reference to the array. And then what is the index of this value? The second indexed, it is going to be 2. And what is this console log going to give us? The console log is going to give us a value of 3. This is comment. That's it for this challenge. See you in the next one. Hi everyone. Welcome to your third challenge solution for arrays. The statement for this challenge says, create an array of 2 Boolean values. Let's go ahead and let's create that. Just put down the red marker and grab the green one. We're going to create a variable, and the name doesn't really matter at this point. And I'm going to call it my array1. I've called it this in the solution. And it doesn't really matter what the name is. And this is 1 in case you're wondering about it. This is the name of the array, and it is going to hold Boolean values in the form of an array. So it's going to be an array and with the values for a Boolean. So the only 2 values that this array is going to hold are going to be what? True and false. So I'm going to create the array, just get the ink to the tip of the marker. There we go. And then I'm going to say true and false. Now these 2 values, it doesn't have to be true and false. It could be true and true. They could be false and false. They could be false and true. So any combinations, as long as they're Boolean values. Other values like a string or a number, they're not going to actually work there, and we are going to end up with a type error or a compilation error. And that's it for this. Why I keep saying for this exercise. See you in the next one. Hi everyone. Welcome to your very first challenge solution for tuples. In this challenge, the requirement is to create a string type tuple. So let's go ahead and let's jump into that. Now we are going to create that using the let keyword again, and I'm going to say, let me get the black one. I'm going to say let, the name could be anything, so I'm just going to say my tuple. We have already talked about what a tuple is and why we need those and when they're useful. In this lecture, I'm just going to focus on solving this challenge. After I've created my tuple, I need to type annotate it to a string, a type of string. So first off, the tuple syntax exactly looks like the array syntax. And within here, I'm going to write string. Now, in here, we can only store a tuple that is going to have a string. And the string is going to be TypeScript. So TypeScript. And that's it. That's it for this challenge. See you in the next one. Hi everyone. Welcome to your second challenge solution for tuples. This statement for this challenge says that we need to create a number type tuple. So far everything is simple. We're just exercising. We're just practicing what we've learned in preceding sections. So let's jump in and let's create that tuple. I'm going to say let my tuple. And now the previous one you might see in the resource files as having a name of my tuple 1, and that's why I'm going to name this 2. And then we need to type annotate this as well. Now first off, I'm going to write the tuple syntax, and then I'm going to decide what kind of data is going to go in here. I want to create a number type tuple. A number type tuple cannot store any other data type. Let's create that. So the tuple syntax first, the data and then the closing bracket. That is it for this challenge. See you in the next one. Hi everyone, welcome to your third challenge solution for tuples. The statement for this challenge reads, create a string and number type tuple and then access the second item. Let's jump in and let's go ahead and let's create that. I'm going to create a string and number type. So it's going to be this is going to be my tuple number 3. My tuple 3. And then we need to type annotate this. Let's do that. We want to create a number type and a string type. So a string, comma, a number. This is going to give us a number type, a string and number type tuple. And now let's insert information in here. The string, I'm going to pass in a string of false. This is not a Boolean, this is a string. And for number, I'm going to pass in 35. Now that we have created these, we need to access the second item. So the second item's index is going to be 1, because the first item's index is 0. And I'm going to say, now if you log this, whatever it is that I'm trying to write here, then it's going to give you the second item. So I'm going to first reference my tuple. This is my tuple. And then using the bracket syntax, I can reference this item that has an index of 1. Now, if you want to see it in the console, the only thing you're going to do is to log it, console. And that's it. That's it for this challenge. See you in the next one. Hi everyone, welcome to your first challenge solution for enums. This challenge requires us to create an enum of product names and display it on the console. Let's go ahead and let's create that. Now, before, you know what, I'm going to create the enum, and then there is something that I need to tell you about enums. We have enum. First, we write the keyword enums, and then what the name of the enums is going to be. So I'm going to say product names, and then we need to specify what kind of products we want to include in here. Now, this could be any product names that you want, but I'm going to include like text stuff. So product names, and then open this one, and let me just populate it with products, and then we'll see where we need to close that off. So I'm going to say product 1. This is going to be product. The reason that I'm writing this a little bit smaller than usual is because there is actually two more challenges that are going to be based on these. So I'm going to keep this here. The second challenge, I'm going to solve it right here. And the third challenge, I'm going to try to solve it down below. I hope you can see that right here. So that's why I'm just writing this small. I'm sure you can still read all of that. So let's go ahead and let's create our products. And this is going to be product 3. And let's assign it. So product 1 is going to be laptops. Product 2 is going to be mouse or mouses. I'm not sure. It's just a mouse, and this is just a laptop, mouse. And then product 3 is going to be keyboard. Cool. So everything is making sense so far. This is how you can create an enum of 3 products. And if you want to display it on the console, that is extremely simple as well. The only thing you need to do is you're going to say console log. I shouldn't even write this, but I'm just going to write it here. And this is going to be product names. Keep in mind that the naming convention for enums, for types, for interfaces, I don't think we have so far talked about types and interfaces. We are going to talk about them in I think in the next section or the one after that. I'm not really sure. I don't have curriculum on here. But we are going to get to them, and you're going to see that they're going to have Pascal casing as well. So I think with this, our challenge has come to an end. But there was something that I needed to tell you about enums. Now, enums are a very, very powerful feature of TypeScript. Now, when we started talking about enums, I didn't actually go over enums a lot, and that was intentional. The reason for that was because I thought that since enums are so important, why don't I dedicate a complete section to enums? So further in the code in this course, you're going to see a section called, I don't know, enums further exploration, something like that. I haven't come up with the name yet. And then you're going to see there are going to be several lectures in which I go over the entire anatomy of an enum, why we need an enum, how this enum actually translates into JavaScript, and why is that important, what kind of thing we get in the JavaScript runtime. I'm going to talk about them a lot, a lot there. By now you can just go ahead and see them. Of course, the course is live now. But at this point right now that I'm standing here, I've not actually covered those, but I've created the curriculum for them. I'm getting way off track. So I'm actually talking about these a lot in those lectures. So that's why in here, I'm not going to talk about how this enum is going to create what in runtime and how is that going to work. This is just going to be the challenge solution, the first challenge for the enums. So with that, this challenge has ended. See you in the next one. Hi everyone, welcome to your second challenge solution for enums. In this challenge, the statement says that we need to create an enum of product IDs and then display it on the console. So let's go ahead and let's create that. Again, I think I have not utilized this real estate on this whiteboard. This is a rather very big whiteboard. And with one challenge, I could have pushed them here to this side, and then I could just solve all three challenges side by side. So what I'm going to do is I'm going to put the second challenge here, and then I'm going to try to put the third one right here, or if I couldn't, I'm going to put it down below, whatever. So this is the first challenge. We're going to need this for the third challenge, and we are going to need the second one for the third one as well. So I'm just going to keep them right here. Let's create an enum of product IDs. We already have our products, laptop, mouse, and keyboard, and I'm going to create an enum for them. This is going to be enum product IDs, and then let me close it off right here. And I'm going to say we have a laptop. Now, whenever you take a look at this enum in the console, you're going to see that the enums, they actually start from 0 if you don't provide them with any value. But if you provide them with 1 or 2, then they're going to start from that number, and then they're going to be incremented by 1 for the next one, and then it's going to go on like that. Since I don't want this laptop to have an ID of 0, I am going to say I want it to start with an ID of 1. For mouse, I'm not going to specify anything, and I did forget the commas right here as well. For mouse, I'm not going to specify anything, and then we have the keyboard, for which the ID will be chosen by the enum itself as well. So this on the console is going to look like laptop 1. There are going to be 6 objects. Again, I don't want to dive too deep into this topic since I am actually intending on creating a complete section for them. I talked about that in previous video. So this is going to be 1 plus 1, incrementing by 1. It's going to be for mouse, it's going to be 2, and for keyboard, it's going to be 3. So that's it for this challenge. And the way that you can log it, you can basically say instead of product names, you're going to say product IDs. And that's it. It's very simple. So that's it for this challenge. See you in the third one. Hi everyone. Welcome to your third challenge for enums. In this challenge, the requirement is to create a favorite product enum that is going to contain one of our products from these two enums to previously created one, and then we need to show it like to the in the console as well. First off, I'm going to create the enum, and then we are going to go over what kind of information we need to write within that enum. And I don't think I can fit it right here, so I'm going to write it here. It's going to be enum first, then I'm going to have a favorite product. There we go. And this is an enum. Let's keep that in mind. And I'm going to close it off right here. I'm going to provide a name and an ID for our favorite enums. So I want to grab the name from here, and I want to grab the ID from here. So we need to provide a name and an ID. So the name is going to be equal to. So first off, I need to reference this enum by the name, which is product name. So let's just reference it first. Product names. And as soon as I do the dot notation, since this actually produces a JavaScript object, we have access to this dot notation. And as soon as I do that, we have access to product 1, 2, or 3. And I want to grab product 1. And what is this going to give me? This is going to give me a laptop. Now I'm going to create the ID for my product, which is going to be equal to product IDs. First, let's reference this enum. And then as soon as I do dot, I'm going to see laptop, mouse, or keyboard. And I'm going to get the laptop. In the challenges solution, so I hope you can see this. This is very simple right here. There we go. So this is the solution for the challenge. But the challenges solution also requires us to display this on the console. Now, the way that I've done that in the challenges solution is that I've actually logged it using backticks or template literals. And I've used template literals to get the value. So you're going to see something like my favorite product is favorite product.name with an ID of favorite product.id. Now that is very simple, and I don't really have to write that here. So I think that is it. So this was the first challenge for enums. This was the second challenge, and this is the third one. And that's it for enums. See you in our next challenge. Hi everyone, welcome to the conditionals challenge. This challenge states that print congratulations if the person's age is 21 or older. So let's go ahead and let's do that. First off, we need to create a variable that is going to hold the age. I'm going to say let age, and we need to type annotate that as well. This is going to be of type number. The age is going to be of type number, and then it's going to be 21. Let's create our conditional. We are going to say if age is greater than or equal to 21, what do we want to do? We are basically going to print console.log congratulations, congrats. I'm just going to simplify it to congrats. And that is it. That is it for this challenge. See you in the next one. Hi everyone, welcome to the loops challenges solution. The statement for this challenge says that based on this array of search history of a user, return would you like to learn how to create websites if there is a keyword HTML or CSS. You probably have already attempted this challenge, so I'm just going to jump into the solution. So we have this array. This array stores values, and each value is a search term. So one is how to make money online, benefits of eating garlic, HTML CSS tutorial, and calisthenics. Now, Our job, our task is to sift through these, and based on each entry, we need to find in two different keywords. One keyword is HTML and the other one is CSS. Now it's easy to find it just by looking at this, but we need to find it programmatically. And after we have found them, if there are those HTML and CSS within the search history, we need to tell the user that would you like to learn to create websites for free? That is basically the message that we want to show to the user. So let's jump in. There are going to be two different versions for this solution. One is going to be using the for of loop, and the other one is going to be the good old map method. And let's just jump in and let's solve this. For both the versions, first off, I could just say, where should I write that? Right here. I'm going to say this is the long version. Awesome. I mean, like both ways is fine. If you want to do it both ways, it's fine. But I'm going to show you, okay, which way is easier to do and which way is better to do. So first off, we are going to grab our search history since that is the array, our array. I'm going to grab that. I'm going to say search. You know what? I'm not going to go through that way. We're going to iterate through this using a for of loop. So I'm going to say for, and then we need to specify a loop variable. That loop variable is going to iterate through this loop. I'm going to say for let search history. I'm going to say search item. Search item. Now this search item is the loop variable that is going to iterate over this loop. For let search item of search history. Now we have referenced that, and what do we want to do? I've opened the code block right here. Now when I say this search item is referring to each one of these. Cool. So I have said that for search item of search that, we could take a look at that in the console, but since the console doesn't really work here, I'm just going to show you something that is really cool. If you grab the search item, we are going to grab each search item and we are going to split that at the commas because we want to grab every individual search item, and then within every individual search item, we want to take a look. We want to look for two different keywords. Now, I'm going to say search item dot split. You can take a look at this in the console. I'm going to split it at an empty string. Very cool. And this is going to give me each of these in the form of an array. Now, every search item has become one array. So it's like this is one array, another, and another. Now it's like one level down. And then we are going to grab these four arrays that we have created, which are represented using the search item, and we are going to iterate through them again. So for that, what I would like to do is I'm going to say for, again, for let entry of search item. Since search item now represents each array, one array in each iteration. And as soon as we do that, we can take a look at the entry in the console as well, which is going to give us like one array, one of these words. And then now when we are iterating through an array, we get individual items. So entry at this point, let me just get the red one. At this point, entry refers to every individual word. So what we are going to do is we're going to write a conditional. So I'm going to say if entry is equal to triple equal, if entry is equal to HTML, and then if entry is equal to HTML or the logical or operator, or entry is equal to CSS. I'm not sure if you can see that. Let me open the code block. Let me just take a look at it. Yeah, you can see that. So if entry is equal to HTML, or if entry is equal to CSS, it means that we have found our search items. And then what we are going to do is we are going to tell the user that we want to log to the console. So console.log. And that is going to be, would you like to learn how to create websites for free? So I'm not going to write that. Now let's close these declaration blocks, these code blocks. So the if statement is going to close right here. And down below that, this for loop is going to close right here. And for the final one, it's going to close right here. I'm going to go over the syntax one more time. And there is 6 minutes. We still have time. So I said for let search item of search history. This is going to give me every individual item within the search history. And then when I split it, this is basically splitting them at the at a space at a space. That is why there's like that space there. At an empty space, we are going to separate these, and this split is going to put every individual item within an array. So at this point, search item is like this. So I'm just going to write that. I'm going to grab the third one. So it is HTML, comma, CSS, comma, tutorial. And it puts it in an array. Now, when it puts that within an array, we are going to do another for of loop. We're going to say for let entry of search item. And at this point, entry could be HTML, could be CSS, could be tutorial. And then we do an if statement. We say if entry is equal to HTML, print this. If entry is equal to CSS, then print this. We're using the logical or operator because if we use the logical and operator, it is going to only hold true if both sides are true. And our task is to print that message if either we get HTML or CSS. So it's not a requirement to get both of them. That's why we do that. So now that that is done, oops, I should not have removed those. I'm going to put them back here. We are going to go through the shorter version. And I could just write the shorter version right here. So the shorter version is using the map method. And I'm going to be a little bit quick since we don't have a lot of time. I'm going to get the search history. And I'm going to say dot map. Now map is going to map through this array. And every time it maps these items, we can apply a function on every individual item of this array. Now keep in mind, even though this is a sentence, this is from here to here, this is an array item. We don't care if it is a sentence or a single word. That is an array item. So I'm going to say map, and then we are going to grab an entry. Let's use the arrow functions, and I'm going to close it down below. Now, for every entry, what it is that we want to do. Now, every entry is going to give me these four. So I'm going to say if the entry includes HTML and CSS, then we're going to do our magic. So if entry dot includes HTML, if entry that includes HTML, or entry dot includes, I'm going to comment a little bit here, includes CSS, and it closes off there. If entry includes these two, then we are going to basically print our message. So what is our message? The message says console.log, console.log, and then that whatever the message is. You can just write it there. And the if statement starts here, it ends right here, and then we have the declaration block for the function, and then the actual map method is going to end there. So now it is up to you to decide which one to use. This is the short weird version. This is weird. Cool. So we got search history, map, and we basically do an entry. This entry is going to be every individual item, and then we say includes HTML or it includes CSS. If that is holding true, then we are basically printing that to the console. So that is it. This is all available to you in the resource files. That's it. See you in the next challenge. Functions are an important part of any programming language, and TypeScript is no exception. In this section, we're going to talk about functions, how we can write functions, how we can type annotate the function parameters, and how we can type annotate the function return statements or the function returns. Specifically, we're going to talk about function declarations, function expressions, as well as arrow functions.
All right, let's talk about functions. In this lecture, I would like to talk about function declarations. And function declarations in TypeScript are in the same manner as we have function declarations in JavaScript. The only thing currently that you need to look out for would be type annotation of all of your parameters and as well as your function. And I'm going to teach you how you can type annotate your function as well. Let's jump right in. I'm going to create a function, and that function we are going to use throughout this section. I think this is going to be the smallest section of this entire bootcamp. We are going to convert this function from a declaration to an expression in our next lecture, and then after that we're going to convert it to an arrow function, so you know all the ways to do a function. The job of this function is to calculate our holiday sales for different products, for different line of products that we have for our company. Functions, we are going to talk about the actual function keyword. So I'm going to say holiday sale. I'm not going to talk about all the nitty-gritty stuff of what functions do, since you already know them, but I'm just going to talk about the TypeScript aspect of them. The first parameter that I would like to provide here would be product. And this is going to specify what kind of product it is. And immediately we need to annotate the type of this product as well. Now, since this refers to a product name, I'm going to annotate it as string. Then I'm going to provide these product sales, which is going to be represented by a number. So you can see this is how annotation works when you are creating function parameters. Very simple stuff. And then let's say we are required to pay tax. Tax is going to be a number of type number as well. And then we also, since this is the holiday season, we are also going to have discount, which is going to be type number. Very simple. And I'm going to save this. I could just zoom out a little, just a little, so you can really see what the function is looking like. Now, this is how I just saved it and it rearranged the code, but I'm going to go back. So you can see we have one parameter, two parameters, 3, and then 4. The first one has been type annotated to a type of string, number, and then number. Now, if I hover on the actual function name, let's take a look at this. So we got function, holiday sales, product has a type of string, sales has a type of, come on buddy, type of number, tax is number, discount is number. But what is this colon? We know what that colon is. We have this void. Now, void is a built-in TypeScript type, which we are going to talk about in our next, in the section after the next section. Next section is again exercises. We're going to talk about void. Void simply means that if the function does not return anything, then it is returning void. It's returning nothing. So void it means nothing in terms of TypeScript. And void is something that is usually assigned to functions. And that's where you're going to see it in other programming languages as well. Now, since we want something to be returned from our function, we are going to specify the type of the return data from the function. Now, this is the good thing about TypeScript. You need to think about all of these stuff. I mean, if you don't know what your function is doing, you need to actually get to know your function. And if you really think that your function is doing nothing, then you don't need it. Just go ahead and get rid of it. Now, TypeScript makes sure that you really understand all the intricate parts of a function. You need to understand what your parameters are. It's not like I would say, okay, in here I'm just going to add like foo, and for these sales I'm going to add bar. No, it's not like foo, bar, whatever. You need to actually be able to work with actual data, what it is you're actually trying to do here. All right, and we are trying to calculate holiday sales. What does that mean? It means at the end of the day, we want to know how much we have sold. So how much we have sold, isn't that a number? That's a number, right? So what I want to be returned from this function would be a number. Cool. So far everything is cool. Now there is an underline there. If I hover on it, let's see what it says. A function whose declared type is neither void, you now know what void means, nor any, must return a value. What does that mean? It means since you have decided, it is the TypeScript way of telling us that since you have decided that this function returns a number, the block of this function doesn't return anything. It has to return something. And we are going to get to that return later in this video, because we got to do a little bit of stuff. Now, I would like to initialize a variable, and I'm going to call it price. The type of this variable is going to be of number, since it's price, and I'm going to initialize it as 0. Now, the products that I'm about to write here, they are like example products. You can change them, you can do whatever you want. This is just an example. So I'm saying if product is equal to sunglasses. So let's say we have sunglasses. If our product is sunglasses, then I want the price for every individual piece of sunglasses, a pair of sunglasses, would be $29. And then I'm going to copy this 2 more times, and I'm going to change this. Now, the first since we have more than one product, we need to specify what kind of a product it is. Now, if the product is sunglasses, we want the price for that to be $29 a pair. But if it is hats, we want the price to be, I'm not an expert on prices, but I'm just going to price it as $19. And for the third product, I'm going to say shoes. And since I think shoes are more expensive, I'm going to price them maybe like 59 or 79 or whatever. Doesn't really matter. Pay attention to that underline. It is still there because we're not returning anything from the function. If I were to say, okay, return cool from this function, now you can see this underline is gone, and we've got another error that says cool. We could say return 15. And now, since we are returning it doesn't make sense to return 15, but it makes sense for this function. And now this function knows that it is returning something. We're going to get to that, don't worry. So now that we have made the prices for our products, let's actually multiply the sales for every individual product by the price of that product to get the total sales for every individual product. So I'm going to say total sales I could just elongate this, for individual product. Total sales for individual product. Cool. And what is this going to have a type? It's going to have a type of number. And for us to be able to get this, we need to grab the price of that product and multiply it by the sales for that product. And now we can see we have used this product and we have used the sales. Both of them are highlighted. However, these two are still not highlighted. Now that is cool. We are close, don't worry, we are almost done. And what I want to do is I want to return from this function the total sales for individual product. I want to subtract from that the tax and the discount, so we know our what is the actual term. Is it net or is it gross? I think it's gross profit, to just actually get that pure or vanilla or gross. It's called gross profit. Cool. and to just get that profit that we know, okay, we have paid the taxes, we have actually discounted, and now how much we have actually earned in money. So I'm going to say total sales for individual product minus tax. Now the tax is going to be, I'm going to multiply the tax by the actual, this price as well, because tax is going to be in percentage, total sales product. And I'm going to subtract from it the discount as well, times total for every individual product. Now, this is something that I would like to return from this function. And now let's test out our function. And we can see that in here in the JavaScript part as well. Cool. Let's test out our function. I'm going to say const. The first product is sunglasses. We're going to use this very sunglasses. We're going to use this very function in our next couple of videos as well. So we got this sunglasses, and we need to annotate the type, and we should know that. So sunglasses, the job of this is to run this function, right? So to store the value that has technically store the value that has been returned from the function. And what is the type of that value? That value has a type of number. And that's what we are going to assign it to. We are going to annotate it as a number. And I'm going to say holiday sales. Now, let's see. Well, as soon as I say holiday sales, we need to provide the product name, which is a string. So let's provide it. You can see this IntelliSense, it guides you on what to do. Sunglasses, and then I'm going to provide a comma, and then the sales is highlighted. That has a type of number. Let's say we have sold 20 pairs of sunglasses. What was the tax? Let's say it was 0.15. I'm just spitballing. I'm just providing some numbers here. And then let's say, since it was the holiday season, we are feeling a little bit more generous. And we are saying, okay, 25% discount. Cool. And I'm going to save that. And that's everything is okay so far. Let's console log it. And the console log, for me, it's going to be a little bit longer. You can just say console log sunglasses, but I want it to make sense. So the console log is going to say the total profit from the sales of sunglasses. I might be digressing from the point a little bit, from the point of functions in the world of TypeScript, but I would like to take just make sure everything is perfect as much as I can. And it's going to be sunglasses. Sunglasses. Let's save that. Let's take a look at it. So we can see that the total profit from the sales of sunglasses is 348. I'm going to add another $sign, and that is the symbol. That has nothing to do with our template literal. This is just $sign. Cool. 348 bucks. Cool stuff so far, right? And since this sunglasses meets this if statement, we can actually see something. And I could just copy this down below. Next up, and I could copy this one down below as well. I could change these to, from sunglasses, let's change them to hats. And I'm going to change these place of these two. Very cool. So let's say we have sold, I don't know, like 15 hats. And the tax was 0.12, and the discount for hats we have it was like 15%. That's why we didn't sell a lot of them, and the profit from them is $208. I'm gonna do one more since we have shoes as well. And cool, let me grab these shoes. And let's say we have sold 50 pairs of shoes at a tax of 0.08. And the discount was, I don't know, like 45%. We're going crazy. And let's save that. And the profit was 1,386 bucks. You could just create another console log. But you know what? I'm not, even though I have that console log in my reference code, but I'm not going to create it because it's like digressing way too much from the point of this entire lecture. So this is how you would create a function in TypeScript. And it's like when you have a variable, when you have a parameter, you need to type annotate it. Now, That's it for this lecture. See you in the next one. Let's convert this function declaration into a function expression. And this is a different lesson, function expressions 3 function expressions.ts. And in this one, we just convert that function that we had from previous lecture to a function expression. But you can see there are some errors. And it says cannot redeclare block scoped variable sunglasses. What does that mean? Even though we have declared it just once in here, the reason that you might be facing this error, well, if you're not teaching it, then you're not going to face it because when you create a project, you're not going to go like this, like function declarations and then function expressions. The reason that it throws that error is because we have the same server for TypeScript when we are running tsc space -w when it's watching, and when it is watching, it's watching all the files. It's not just watching one. So you could say like common server. And on the server, we have the sunglasses defined, and we have this hats defined and shoes defined. That's why in the next file, we cannot redefine them. And for that reason, I'm just going to set them to 1. So they are 1, 1, 1. And so that error actually goes away. Cool. And I'm going to set it to that. Let's save that. We don't have any issues. We do have this holiday sales. I could just set it to holiday sales. Let me grab all the instances of holiday sales. And I'm just going to add 1 there, just to make sure these two are different from one another. Cool. This is our function expressions lesson. Everything is working correctly. Let's first convert it to a function expression. And we know how we can do that. I'm going to get rid of this function keyword from here, and I'm going to say let holiday sales be equal to this function that we have. I'm going to paste that function right here. And if we take a look at this, you can see that it returns a number. It is still returning that number. And that's it. This is a function expression. Now, to make this video worth your while, I'm going to show you something very cool. Let's say you got a very big function like this, or maybe like even a bigger one, and there is you have provided a parameter in there that you have not actually used, or you might have forgotten to use. And let's say I'm going to change this to department, and you know what? I'm going to change this function up a little bit. I'm going to change the products from sunglasses. I should have probably done this. I'm going to change it from sunglasses to pens, and I'm going to change from hats to erasers. Cool, erasers. And from shoes, let's change it to pencils. Save that. Very cool. We don't need that one anymore. So I could just very quickly get rid of it. And from there, let me get it. Get rid of that. There we go. All the ones are gone. And if I remove this, it's going to throw an error. Just add that holiday one. So we have this department. And let's say it is specifying the department of our products. Now, previously we had the clothes or clothing, and now we have like stationary items. And this is going to be represented by a type of string. But we have not used it anywhere in our code. Cool. What is this error? It says expected 5 arguments. We're going to come back to this. It says expected 5 arguments, but got 4. And that is all the way down here. All the way down here. If you don't run your function, you're not going to see any kind of error. So I'm not running the function. There is no error, even though we have this parameter that we have not used. Now I'm going to jump into TypeScript tsconfig file. And from the tsconfig file, I'm going to add another setting that is going to allow us, that is going to basically tell us to make sure when we write a parameter, we also use it. Cool. It's going to give us like a little bit of a warning. And that is going to be, why are you typing there? No, where is it? No unused no unused parameters. And I'm going to set it to true. Cool. I'm going to set it to true. Let's save that and let's jump back in here. And I can see there is a warning. It's not an error, it's a warning. And if I hover on that, it says department is declared, but its value is never read. Now this is actually very cool that you can do in TypeScript. So from now on, just make sure to add this to your tsconfig file. In our next lecture, I'm going to show you how to add another setting in here within in your compiler to check for something else in a function. I'm not going to give out the surprise. So I'm just going to comment all of this back in and save it. We can see our function works perfectly fine. All right, let's talk about arrow functions. The first thing that I would like to do is I would like to tell you that I've already changed the products, the name of the function, so there are no errors. I've done that off screen, not to waste your time. The way that we can change this into an arrow function is very, very, very simple. I can just remove that function keyword, and after this annotation of the return key, I'm just going to add that fat arrow that signifies that this is an arrow function. And now this is an arrow function. Very simple. And there is nothing else that I would want to do to this function aside from one thing. And that is just to make this video again worth your while. What I would like to do is I would like to show you another cool setting that you need to, that is a good idea to be able to add it to your functions. And that is, for example, let's say we have, remember that department? Let's say we want to specify specifically that the department, why is it uppercase? Let department or DPT or department that has a type of string, we are going to set it to tech, whatever, to tech. Now we have this this variable that we have not used anywhere, and maybe this function is like a little bit longer, right? Maybe there is like a lot of other functions. We have a lot of other stuff on our mind. And for some reason, we forget that we have not specified the department. Maybe this is an important thing and we need to specify it, but we have forgotten to do that. Now, how can we make TypeScript remind us that we have some sort of a variable that we have not used? Well, there is another setting for that. And that setting is, now remember this function, this is a function, right? And the code that all the variables that are within this function, it is called, they are within a local scope, because the scope of a function is called a local scope. Keep that in mind. Let's jump into our ts.config file, and I'm going to say no unused locals. And by default, it is set to false. Let's set that to true. What this means is that if there is an unused local variable, show it to us. And it says, and you can see it says no unused locals. It was set to false, which meant it didn't show us that. It was like a double negative, which is actually a positive. Now it is like a negative times positive, but somehow we end up with a positive. I don't want to get into that. But when it says no unused locals, we set it to true. It means that it is going to raise that flag that this local has not been used. Very simple. And now you can see we got an error. And immediately, if I just click on this, it's going to show me that department is declared, but its value is never read. We could see that there as well, but we could hover on it and see it right here. Department is declared, but its value is never read. And if I save that, you can see where is that department? File change detected, found one error. And it's not going to do anything in the JavaScript. Cool. I'm going to put this down. Let's say we remove these two function calls. We comment them out, and we comment these two console logs. And as soon as I save it, you can see because we have this, even though it's a warning, even though we have this error or this bug in our code, the code is not being compiled to JavaScript because we need to fix that. And that is a good thing. It removes all the issues when it comes to functions, all the issues that you need to face when you're actually trying to deploy your code anywhere. Cool. And I just wanted to teach you that as well. And I don't think I'm going to add any more up until now. No unused locals. I don't think I'm going to add anything else in this section, since this section is also done. And for our upcoming sections, what I would like to do is I would like to, when I create the ts.config file, tsconfig.json file, when I create this compiler options, I'm going to copy all of this and I'm going to put it there. And you need to keep that in mind, because in every folder, we are going to have a different config file, and I'm going to put all of this there. And I want TypeScript to tell me if I have unused parameters, and I want TypeScript to tell me that I have unused locals. There is just something that I need to mention right here before wrapping this lecture up, is that these are preferences. And these preferences, they actually make your code a lot better. They make your code look a lot more professional. I'm going to comment this one out so we don't have any kind of errors. And if the more you use these kinds of tools to your to write better code, you're going to end up with a much more professional code that is way more acceptable among the community than like a sloppy amateurish code. And this basically helps you enforce good practices into your programming habits. That's it for this video. See you in the next one.
Hi everyone, welcome to part 2 of Let's Get You Coding Challenges. In this part, we are gonna only talk about functions, and all the challenges, they're gonna be mainly involved around the idea of functions and how to create functions, how to type annotate the return keyword or the return from a function, how to type annotate parameters, and how to keep everything as a type checked system. And the premise is going to be exactly like the part 1 of this series. I'm going to first read the challenge statement, and then I'm going to dive into solving that on my on the whiteboard behind me, not on myself, on the whiteboard behind me. And that's it. So see you in the next video. Hi everyone, welcome to the first challenges solution for functions. The statement for this challenge says that we need to create a function that returns the multiplication of 2 arbitrary numbers and returns a type error when we pass in a string. So let's go ahead and let's see how we are going to go ahead and solve this. Now I am going to create a function first, and to be able to create a function first, we need the function keyword. The name of the function is going to be multiplication. So let me create that. This is going to be this is not T, this is the actual T, that is the L, multiplication. And let's create our parameters. Since we are multiplying 2 different values, 2 different numbers, I'm going to create 2 parameters for them. The first parameter is going to be num1, and the second parameter, I'm just going to provide a comment there. The second parameter is going to be num2. Now, since we are in TypeScript, we need to type annotate these parameters. And the way we type annotate parameters is just providing in front of them what their type is going to be. So that is going to be of type number, and this is going to be of type number as well. Now, so far everything is cool, everything is making sense. Now, what do we want to return from this function? We want to return the result of the multiplication of 2 numbers. So at the end of the day, we are returning a number from the function itself. And after we have completed the parameter parentheses, we are done with the parameters. Right in front of that, here is where we type annotate the return result from the function. So if the function returns something, that thing has to have a type. I mean, you can't say, okay, returns something. No, it has to have a type. But if it doesn't have a type, it means that it doesn't return anything. That's simply what it means. And when the function doesn't return anything, for example, the function basically logs something to the console, then, or it does something and then, or maybe it invokes another function, something like that, then what we should do is we should say that the return type is going to be void. But in this specific example, it's not void, it's not nothingness, it is actually a number because we're multiplying these. So the return type from the function, return type of the function is also a number. Let's open the function right here. Now, what do we want this function to do? We want this to return the multiplication of two numbers. So I'm going to say return num1 times asterisk num2. That's it. That's the only thing that we want this function to do. Now that this function, actually this has to be like right underneath the keyword itself. So now that we have created the function, we need to invoke it. In the solution, I've actually invoked it 3 times. You can take a look at that. The function is complete. So we are going to call the multiplication. The way that we invoke a function is that first we need to refer to a function. We need to reference that function. So you might have like 100 functions in your app. Which one do you want to invoke? First, you need to refer to that function, which is multiplication. Now, there is something that I need you to keep in mind. Whenever you write the name of the function, this is like passing a reference to this function. We are directly referencing the function here. But invoking the function is something else. Invoking the function is like this. So now we are invoking the function. So the job of these two parentheses, or these parentheses, is to invoke the function. Cool? So this is passing a reference to the function, and this is calling the function. And then passing in the values that we want. So for num1, I could do 1. And for num2, I could do 5. There's like a little bit of space. I could just shorten that. So it's 1 and 5. And num1 times num2, that is going to be 5. For the second one, what I could do is I could just say this one like that. So 3 more times I'm going to invoke the function, or I'm going to call the function. The second time it's going to be 115. 15 and 5. This is going to be like 115 times 5. And the third one is going to be 115 times string of 5. And this is going to throw a type error. I'm going to shorten it like 2 more times as TEY. This is actually a compilation error. And this is saying like type string is not assignable to type number. Why? Because this 5, it is this num2, it is this num2 parameter. This is the value for it. And it clearly says number here, almost clearly. And when you pass in a string, string is not assignable to type number. And that's it. That is the solution for the first challenge. Everything is cool, so let's move on to the next one. Hi everyone, welcome to your second challenge solution for functions. The statement for this challenge says that we need to simulate a type error for the returned value of a function that has an arbitrary type. So the return type could be a string, could be a number, could be a boolean, whatever. But we need to simulate a type error for that specific arbitrary type. It's simpler than it sounds. Let me create the function keyword itself. So function. The name of the function, I'm going to say email list. Email list. And the job of this function, the task that this function is going to carry out, is going to be to grab emails for us. So I'm going to say email. And I'm going to store the emails as a string. So I'm going to type annotate this parameter as a string. There we go. So far, everything is making sense. And now, since this is a string, and the only thing that I want this function to do is return the email, that's why the return type of this function is also going to be a string. Now, again, this is like arbitrary. This is something that I'm just writing here. You can change it to whatever you want. The point of this exercise is to simulate a type error, the kind of type error that you saw in our previous challenge. Now, what do I want this function to do? I want this function to simply return emails. So I'm going to say return email. That's it. Now, how are we going to simulate a type error for the return type? The return type is string. If you pass in anything else, any kind of data with any other type, that is going to simulate basically a type error for us. So I'm going to say email list. And now I could just pass in something in here. And that thing could be the number 50. And this is going to simulate a type error for us. So it could be 15. It could be like you pass in true. As long as you don't pass in a string, it is going to simulate that type error. And I think that's it. That's it for this challenge. See you in the next one. Hi everyone, welcome to your third challenge's solution for functions. The statement for this challenge says that we need to create an arrow function that returns the addition of a number and a Boolean type. Let's jump in and let's create that. I'm going to create an arrow function, and that is going to return the addition of a Boolean and a number. So I'm going to say let's call this function add. And let's see what this function is going to take as parameters. So it's going to take two parameters. One parameter is going to be num, and the other parameter is going to be bool. And I'm going to close the parenthesis right there. So the type for num is going to be number, and the type for bool is going to be Boolean. Since the job of this function is to return the addition of two numbers, a number and a Boolean, we assume that this function returns a number. That is a good assumption, right? Now, what do we want this function to do? We just want it to return the addition of a Boolean and a number. Now, the idea here is not to combine, add a number and a Boolean. We can't do that. That is going to throw a compilation error. But the idea behind this challenge is how are we going to proceed further? So are we going to create like a code block, a block of code, a block for this function, and then we're going to say return this? Or are we going to go ahead and suffice to the implicit return from an arrow function? We can't do an implicit return. So that is the main idea of this challenge. Let's do an implicit return. So this is the fat arrow. Now, when you take away these two, these curly braces, when you take them away, it is thought or it is inferred that the function returns something. So when you take away the curly braces, you don't need the actual return keyword as well. You can take that away as well. So what you're going to end up with is, you just say you want to return num plus bool. Num plus bool. And that's it. That is everything that we wanted this function to do for us. Now, this is going to throw a type error. And if you just go ahead and write this in VS Code, it's going to say that this operator cannot add this with this. But that's not the point. The point is that now we know how arrow functions, if we don't provide the code block, they're going to have an implicit return, and we don't need that return keyword as well. That's it. So I think that's it for this challenge. See you in the next one. Hi everyone, welcome to your fourth challenge's solution for functions. In this challenge, the statement says we need to create a function that makes words pluralize. It pluralizes the words by adding like an S at the end of them. So let's just jump in and let's solve this. First off, now what I'm trying to do throughout these challenges is, you might have noticed that I'm trying to use every kind of function that we know in JavaScript. Like I did like I think a couple of challenges with function declarations. Then there was a challenge with an arrow function, and now this one is going to be a function expression. So it's a good idea to know all three types, and you could technically use only one for your application, but it is good to know because some people, they might have different preferences. So if you see an arrow function, you should be able to understand that it is an arrow function. But if you are used to using arrow functions a lot, you see a function declaration, you should be able to distinguish that that is a function declaration, this is a function statement, and how these things actually work. So let's jump in and let's solve this challenge with a function expression. I'm going to create the function name first. Let me just get the ink to the tip. The name of the function is going to be pluralize, and then we need to add the function keyword. After we have added the function keyword, now I should stay consistent, and the name, I'm gonna write it in black. So it's gonna be pluralize. Cool. Now within the function itself, we just want to receive a string and add an S at the end of it. Now we are not going to jump into too much grammar of English, like some strings they need ES, like class, glass, something like that. But I'm just going to keep it simple, and I'm just going to say, okay, just add an S, and that's it. So what we are going to do is we are going to need a parameter, which is going to be, I'm just going to type it as string, stir, and the type, what am I doing? I have to type it with the red one, right? So the type for this one is string. Stir is the name of the parameter, string is the type of that parameter. And then what will this function return? It's going to return a string as well. So the function return type is a string too. Now let me just open this here and close it right here. We want to return from the function by adding stir plus like an S, and that's it. That is the solution to this challenge. You could test it. Since I don't have access to log in the whiteboard, I'm just going to write it. You just grab that function invocation and throw it in the console log, and it's going to show you something. So I'm going to say we have the pluralize function, and what I'm going to do is I'm going to pass in a string. The string is going to be cake. And as soon as we do that, what will the function return to us? The function is going to return to us cakes. That's it. That's it for this challenge. See you in the next one. Hi everyone. Welcome to your 5th challenges solution for the part 2 of the series. The challenges statement says that we need to write a function that adds 1 to a number or subtracts 1 from a number, depending on a Boolean evaluation. So if the Boolean that has been passed is true, it adds 1. Otherwise, which is like when the Boolean is false, it subtracts 1 from the number that we also pass in. So we pass in a number and then we pass in a Boolean. Depending on the Boolean, we either add to that passed number or we subtract 1 from that passed number. Let's jump in. Now, this is going to be a little bit more fun, and there are going to be actually 2 different solutions. two solutions. Both of them are going to be different in the sense of what kind of logic we are going to use, and which one is shorter, which one is longer, so it's going to be up to you. Let's jump in and let's do this challenge. I seem to have function declaration, so I'm going to be using function declaration. I'm going to write the function keyword here. The name of the function is going to be decide operation. It's going to say decide operation. And we need to pass in a number as well as a Boolean. The number is going to be the number that we either add 1 or subtract 1 from it, add 1 to it or subtract 1 from it. And then the Boolean is going to be used for that evaluation. I'm going to type annotate these, this one to number, since this is a number, and this one is going to be Boolean. Now that we have type annotated these, let me close it off right here. We need to come up with the type annotation for the return key, for the return value from the function. Now, what do we want to do? We want to either add 1 to a number or subtract 1 from a number. So at the end of the day, we will be left with a number. So that's simple. I can just say return type is going to be a number. Everything is awesome so far. I'm going to open that here, and I'm going to close that right here. Now, first, we need to check whether this Boolean that the user has passed is true or false. Since we just have to, it's very simple. So it's like this or this. It's like one or the other. So it's very simple for us to come up with this check. I'm going to use the if statement, like the classic way of solving these kind of challenges. I'm going to say if. Now, what I'm going to do is within here, and then I'm going to do it like this. Cool so far? Let me just put this a little bit down so there is a little bit of space here. Now, if Boolean is true, then we want to add 1 to that number. So from this if statement, what do we want to return? Not return. Let me just, okay, there we go. So from this if statement, we want to return num plus 1. Now, whatever you pass in within this definition of the if statement, it is going to be evaluated in a Boolean context. So if Boolean is true, it means that when we call the function, when we pass in true, that value is going to be passed here. If is going to be true, then this is going to run. But if this is false, this if statement is not going to run at all. And then what do we want to run instead of this if statement? We want to return from the function. This is R. Return from the function. It was, if it is true, add 1. So we want to return num minus 1. So it's going to be either this or this. You don't need, in this specific case, you don't need the else key. Why? Because this if statement, it's only going to be evaluated or executed if this condition is true. If this condition is not true, it means Boolean, the Boolean value is false. This if statement is not going to run. So we are automatically going to come to this return, and you can see that this return is outside the if. So this return belongs to this function. And we are going to immediately return from the function. Now, if the Boolean value is true, it means that this is going to be the return key for the function. And we know that when we have anything after the return key for a function, that's not going to run. So when this runs, this thing is going to automatically become deactivated, like faded out, and it's not going to run. So this is one way of going about it. We could also simplify this code. I could get rid of that. I could get rid of this and get rid of this curly brace, and I could just put all of them on one line. We could do that as well. So I'm going to say this is num plus 1, and let's add in the return key. There is not a lot of space, So I'm going to write it here, return, and then let me close off the parenthesis right here. So if Boolean is true, we return num plus 1 from the function. If Boolean is false, this is not going to run, and then this is going to run. So this is the longer version of the function. We could just shorten this in like one go as well. Now, for that, I could waste your time and create this entire function again. But what I'm going to do is I'm going to shift this upwards, and then I'm going to comment both of them out on whiteboard. So this is commented out, and this following line is also commented out. So I'm going to say return num minus 1. Num minus 1. And now I'm going to get rid of this. So this is, let's use the green one. So it's a little bit more obvious. So this is the long answer. And this one is going to be the short one. So short 1. Cool. That was, so if you just work with this, it's going to be okay. It's going to work, and you don't have to worry about anything. Now, what is the short version? We know that the shorter version of the if statement is the ternary operator. Now, the reason that we can shorten this is very simple, because we just have one condition, and that is the perfect application for a ternary operator. Now, how would we go ahead and do that? Now, where is our condition first? We need to first check for our condition. Now, the condition says that the Boolean value, it has to return true. And we need to keep that in mind. So the true is going to come from the user. That is going to come from the function argument. So I'm going to say, I'm just going to write here bool. Now, when this is true, whatever comes after the question mark is going to run. If this is false, whatever comes after the colon is going to run. Very simple, right? So we are saying that if Boolean is true, which condition is that? That is num plus 1. So I'm going to say num plus 1. If bool is false, then this is the else part of this ternary operator. We're going to say num. So when this if statement is false, we immediately jump into what? We immediately jump into this return key, which is, oops, it's not oops, this is oops, which is num minus 1. I think I don't need to explain this again, or should I? I mean, if you nod, I'll definitely understand that. So I'm going to go ahead and I'm going to explain that again. Now, so the only two values that this bool is going to take, now keep this in mind that this side, now if I do it with a red, you might think this is an error, but let's do it with a green. So this side of a ternary operator, this is like Boolean evaluation, eval. Now this Boolean evaluation is the same thing as we had here. This is also Boolean evaluation. So these two are the same thing. They can only produce true or false, or truthy and falsy. So they can produce true. If it produces true, which means that Boolean true has been passed, this side is going to run, and this is going to be true. If bool is true, like this, if bool is false, then this side is going to run. That's it. That's basically this. And I hope you're not getting confused, since we are like diving too deep into these topics. I should finish the lecture since I don't have a lot of time. Let's invoke the function. Not that we can know whether or not the code is going to work, but still. We are going to say decide. Now, in the solution, I've basically stored it so we can see it in the console. You can do that, but I'm just going to invoke it right here. Decide operation. And it's going to be 1. And let's do 2 invocations. I have a lot of markers in my hat. Let me put them there. For the first one, I'm going to do 10 and true. For the second one, I'm going to do 10 and false. Since we are using TypeScript, we can't pass in anything else. So it's like we have a type-safe system. We can only pass in for the bool only true and false, and for the just numbers. It could be any number, but we can just pass in numbers. Now, if I pass in 10, that is going to be 10. This num is 10. And for the first one, 10 and true, it means num plus 1. The result is going to be 11. And for the second one, I'm going to evaluate it in here. Since Boolean is false, which one is going to run? This one, num minus 1. That is going to be 10 minus 1, which is going to be 9. So that's it for this challenge. See you in the next one. Hi everyone, welcome to your 6th challenge of this section. In this challenge, the statement says that we need to create a function that takes in an array of numbers. And it just returns that array. It doesn't do anything to the array, it just returns it. But if anything else is passed within that array, like a string or Boolean or anything else, it throws an error. Let's go ahead and let's see how we are going to come up with this function. Let's go ahead and let's create the function first. I do have a function declaration, so I'm going to use a function declaration. Function. This is the keyword. What is going to be the name of the function? It's going to be my array. And this is going to accept an array. Now, how are we going to type annotate this? First things first, we need to come up with the name of our parameter, which is going to be array. And then we know how we can type annotate that. Now, whenever you want to type annotate an array, the first thing that you need to provide is these brackets, square brackets. And then, what did the challenge say? The challenge says that we need to take or accept an array of numbers, right? Yeah, an array of numbers. So this is an array. How can I write numbers? We know that, right? We are just going to write here number. That's it. So now this function's parameter can only accept an array that is of type numbers. It doesn't matter how many numbers, but there can't be a string or a Boolean value or another array or an object, nothing. So it just can only accept an array of numbers. And then the functions, the challenge statement says that this function, it has to return this array. It doesn't do anything to the array, it just returns the array. So the type, return type, is also an array, but what kind? Since it is requiring an array of type number, and it is returning it, so the return type is going to be the same thing as well. Got it? So it accepts this array and it returns it. That is what the function does. So when it accepts an array of numbers and returns it, and does it do anything to it? So it basically returns an array of numbers. There we go. And let me open that here and then close it here. And then we are going to say return. What does it return? The parameter. Very simple. So far everything is making sense. Now, let's go ahead and let's invoke the function. It's going to be my array. This is 1 time, this is 2 times. And I think that is enough. I think this is enough as well. So the only thing that this function can accept is an array. That's it. The function cannot accept anything else. Now, in this case, I'm going to say 1, 2, and 3. And the function is going to return for me the same thing, 1, 2, and 3. But in this case, if I pass in 1, string of 2, and then 3, this is comma. This is not 9, this is comma. And then it's going to return a compilation error saying type string is not assignable to type number. Something like that. So in this case, it is going to throw a type error. And that's it. I think that is it for this function. So that's it for this challenge as well. See you in the next one.